Hey all my dear champions, I Abhinav Negi welcome you all on BYJU'S Exam Prep Civil Mechanical Exam channel. And guys, today will be the special engineering mechanics marathon that will be complete engineering mechanics marathon will be going to do today, and me, Sonu sir and Dheeraj sir. Okay, this will be complete including all 8 chapters of engineering mechanics. So guys, be seated, be ready for this complete engineering mechanics marathon. Yes, engineering mechanics is not that as high weightage as other subjects like soil, environment, or for mechanical it is production, but yes, gradually year by year the weightage of engineering mechanics is increasing, and this is also the base for doing many other problems of strength of materials or even fluid mechanics or tome and other things. Okay, yes, the super duper Sonu sir is also here from Badod, Ahmedabad. Okay, so guys, moving further, this is about me. My name is Abhinav Negi. I'm from IIT Delhi, but yes, of course, this is not coming in examination. Let's come further. You can find this PDF in Civil by Abhinav Sir Telegram group. You can find this in Mechanical by Sonu Chauhan sir Telegram group, also the combined PDF of all three. Okay, and you can find this in Mechanical by Dheeraj sir also. Okay, Mechanical by, in all these 3 telegrams you'll be finding this complete PDF. Okay, so guys, this is the syllabus. Of course, guys, please take your pen and copy along with you to get the full benefit of this session. But guys, please don't write anything that is already written here. Only write those things if something I am telling you, you like it, you enjoyed the concept, but that is not written in the PDF. Okay, because anyhow we are giving this to you. Okay, excellent. So many students are here. So guys, please make a heart sign if you all are ready. Everybody on the comment section, guys. Good evening sir, good evening everybody. Guys, please put a heart sign on the comment box if you are ready. Come on everybody. Chalo bhai, chalo. Yes. Okay, Raghu, everybody is here. So guys, in engineering mechanics will be 5 to 7 marks. Okay, usually it comes off for civil, it is 3 to 4 marks and 4 to 6 marks for mechanical. But yes, year by year, engineering mechanics weightage has increased. One time it was of 1 marks, then 3 marks, and guys, in last couple of years, if you see, for mechanical especially, it is 4 to 5 marks, and for civil it is 3 to 4 marks. Now for the books, this is the books you can written here. You can refer these books, but for 2023 students, of course, they all know, I don't have to recommend this, that you can't read this whole book. If you read this whole book, then other subjects will be missed. For 23 students, just what I am telling you, that is much more important than plus practicing numericals and revision in test series. For 24-25 students, along with this marathon, you can go for these books also, because you have sufficient time. Okay, so many students are here, and I guess everybody is ready. Okay, so guys, this is the syllabus that we are going to discuss today. Okay, that will be, guys, enough for all examination. Okay, I'll be now all these 8 chapters what we will be taking in this particular marathon. Let me tell you that also. So guys, here first chapter I will be taking. Okay, that is system of forces and free body diagram. That includes the contact force, all types of forces, plus the vectors, plus scalars, and how the vector product has to be done. Okay, how if there are so many forces, then how we can concentrate on one single force. Free body diagram especially, that I'll be telling you, that will be used in tome, dome, and it will be used in engineering mechanics everywhere. Okay, then guys, truss will be taught by Dheeraj sir, friction by Dheeraj sir and Sonu sir combined, kinematics, kinetics, and moment of inertia, center of gravity, work, power, energy, and Lagrange's theorem will be done by Sonu sir. Okay, guys, ready? I am again telling you, I am dealing with this, guys. This I will be dealing. Okay, and then this will be dealt by Dheeraj sir. Okay, this Dheeraj sir and Sonu sir both, this Dheeraj sir and Sonu sir both, and here the kinetics part will be done by Sonu sir. Ready, guys? Everybody, please let me know in the comment section, guys, and keep sharing the video so that more and more commandos can join in. Everyone. Okay. Let me share in my telegram also. So that more and more commandos are here, and they will not be missing the session in that case. Okay. Let's begin then. Okay, let's begin then. So guys, mechanics is the branch which deals with forces and its effect. Force will be there and what will be its effect. Let me tell you now, this effect will be again of two types. One will be the internal effect. Internal effect will be, see, let me tell you guys, if this is a body and you are applying some types of forces on this, then there will be two effects. One effect will be internal, that internal deformation, elongation of this body, deformation of this body, elongation of thickness, something may happen or orientation may change, that is internal. And one is external, that this body may go in a motion and after some time it may reach here. So here we are going to study the external effects. Okay, the motion of the body and all these things. And if it is rest, then we are seeing the external forces only. Okay, strength of material is a subject in which we will be seeing that how much this is deformed or how much is elongated, or might be in one direction it is elongated, another direction it is deformed. That we will study in strength of materials. Okay. Now, suppose guys, what is a deformed body and what is a rigid body? Everyone. What is a deformed body and what is a rigid body? In engineering mechanics, we deals with rigid body. Okay. In engineering mechanics, everyone please see, in engineering mechanics, we are dealing with rigid body. Okay, rigid body. Whereas in strength of materials, we will be dealing with deformable body. Now, what is a deformable body and what is a rigid body? Guys, if we apply a force on a body and after application of force on a body, if the earlier distance between A and B is x and after application of force it is again x, if before application of force it is x and after application of force it is also x, both are equal, here x and x dash both are equal, then that body is a rigid body. And if after application of forces here the distance may increase or decrease, it is not equal, then it is a deformable body. Okay. Now guys, not only the distance, might be this is a body and x is here and x dash is here, and now x is equal to x dash, but theta changes, then that kind of body is also deformable body. So not only the distance, but the better word will be the relative position. If the relative position of those two particles changes, then that is a deformable body. Might be distance is not same, or might be the orientation is changing, then also it is a deformable body. Now let me tell you, everybody on the comment box guys, come on everyone. Suppose this is a body and if I am compressing it, so this is a deformable body or rigid body, please let me know in the comment section. If I am compressing this, this is a deformable body or rigid body? This is a deformable or rigid body? Everyone, Teju, Raghu, everyone. This is a deformable or rigid? This is a deformable or rigid body? Everyone, please let me know. And since the position is changing, displacement is here, this is deformable body, and if this is an iron, here if I am applying forces, what kind of body is this? What kind of body is this? What kind of body is this if I am applying the force? If I am applying the force, what is this body guys? Come on, please let me know. What is this body? Everyone, this you are saying on the, guys, that balloon is a deformed body and this you are saying rigid. Okay, Raghu is saying rigid, Naveen is saying rigid, Nagasai is saying rigid, Sanjay correct. Guys, all are wrong except Sanjay. Muhammad is also wrong. This is also a deformable body. Guys, everything in this universe is a deformable body. Rigid body is just a pure assumption. Yes, here the deformation is not seen by your naked eyes. From your naked eyes, you are not able to see the deformation, but that is also a deformable body, guys. Everyone. Everything is deformed. Guys, delta is PL by AE. E is very high, 2 into 10 to the power plus 2 into 10 to the power 5. So delta becomes very small. That doesn't mean that only the seeing which you are able to see, that is only deformable. All the things are deformable, guys. Everything in this universe is a deformable. Rigid body is just a pure assumption. Okay. Now moving further, rigid body and deformed body I have told you, and moving forward. Now guys, if I differentiate the mechanics, it is a static part where the acceleration will be zero, the body is at rest, and one is dynamics part, and dynamics is further classified in kinematics and kinetics. Kinematics means we'll be seeing the motion of a body. Kinematics means we'll be seeing the motion of a body, and kinetics in this part will be seeing the forces which causes motion. Here we'll be seeing the forces which causes motion. Okay, and here we are only restricting ourselves to the motion, velocity, and what is the change in velocity and all these. We are not dealing in the cause. We are not going into the forces. Okay, and here we are seeing on the body which are rest. Okay, absolutely rest. Yes, Rajat Mishra, good evening. Please share the session, guys. So scalar quantity are all we know. Yeah, scalar quantity is those we have only magnitude, no direction. Vector means they have magnitude and direction. You might be saying this. No, vector means three things: should be having magnitude, should be having direction, and should follow parallelogram law of addition. That is A and this is B. So this vector is A plus B. Like stress. Stress has magnitude. Stress has direction. Normal stress is perpendicular. Shear stress is tangential. But it does not follow parallelogram law of addition. So it is not a vector. It is some other quantity tensor, two-order tensor. Leave that. Okay, in school NCERT it is written wrong that vector should having magnitude and direction. No, it should be having three things: magnitude, direction, and follow parallelogram law of addition. Now, suppose I want to summation of two vectors, then what to do? Everyone, please see. Everyone, here, please see everyone. Suppose this is a vector P and this is a vector Q. Okay, suppose this is Q. Suppose this is Q and this is P. So now how to resolve this? How to do addition of this? Okay, yes guys, now Dheeraj sir is also here, everyone. So this is Q and this is P. Okay sir. Now guys, if this angle I am saying as the angle between them is theta. The angle between them is theta. Okay, so this will be 180 minus theta. Now P will be having two components. Now see, P will be having a yellow component, horizontal component, and P will be having a blue component, that is a vertical component. Agree? Now this P, if I write this yellow as, this will be P into cos 180 minus theta. This angle will be 180 minus theta, na? This angle will be 180 minus theta, na? I am just representing the magnitudes. So P cos of 180 minus theta. So this will be P cos theta, and this vertical component is P sin theta. Okay, now I am again reminding you. This is a Q vector. Okay, sir, got it, sir. And this is a P vector. Now this Q and P vector, let me tell you in more elaborate way. This was a Q vector and a theta angle. This is a P vector. Now see how I am representing these two vectors. Everyone, very interesting. How I am writing this? This is a Q vector in x direction. Okay, let this be x. And then one more, P cos theta. Agree? That is also in the same direction. Agree or not? Please let me know in the comment section. Both are in the same direction. And in vertical direction, that is P sin theta. Now in vertical direction, that is at 90 degree, it is P sin theta. Everybody, yes or no? And if there is a vertical force Y or Fy and there is a horizontal force Fx, then resultant is equal to Fy square plus Fx square. This we know. Okay, similarly doing this here also, that resultant, suppose this is the resultant. Okay, so resultant here is Fx square plus Fy square under root. So it will be under root of x-axis Q plus P cos theta square plus Fy, that is P sin theta whole square. Now from here, everyone, R is equal to P square cos square theta plus P square sin square theta will be P square. So it is P square cos square theta plus sin square theta is 1 plus Q square plus 2 PQ cos theta. Yes or no? No. P cos theta will be whole square and it will be Q whole square. So from here, it will be 2PQ cos theta. 2PQ cos theta. Everybody on the comment box give me yes or no. Everybody on the comment box give me yes or no. Have you understood or not? Everybody please on the comment box, guys. Soon we are going into the beautiful numericals. Soon we are going into the beautiful numericals. Are you all ready? Have you understood this? Have you understood this? Comment box, I'm seeing your comments, guys. Come on. Everyone, yaar. Everyone. Please let me know. Okay. Now, of course, if the theta vector is here also, okay, it is 180 minus theta, and if it theta also, then also the P will be P cos theta and P sin theta. Then that means the angle between two of them is theta. This angle is theta. This angle is theta. Understood? Okay. Now, moving further, guys, from here, dot product is, suppose this is a work done, is F dot distance. Guys, what is the work done? I'm asking a very interesting question. And you might be thinking that you know the answer, but 90% of you don't know the answer. 90% you don't know the answer. Work done by a coolie in railway station. Work done by a coolie in railway station. Tell me please. Many of you, I am already telling you that you will be saying that you know the answer, but unfortunately 90% might be wrong. If you are correct, I'll be very, very happy. This is the floor. Here is some friction. This is the coolie. And in the coolie, the luggage is like this, which is, I am saying, perpendicular to the distance. This W weight is perpendicular to the distance. Now tell me, everyone, what is the work done by the coolie? What is the work done by the coolie? The distance is here. This is force F. This is distance he is moving D. And the angle between them is 90 degree. Let me know. 0. Okay, Sujesh. Surut. Okay, others. I want everyone's answer. You are saying 0. Let me tell you that you have studied this 0 in your school. It's wrong. First of all, भाई कूली को पैसे जरूर दे देना. ठीक है? 0 गलत है भाई. Work done. Now the answer is real answer. Listen the real answer. Answer, please see. Work done by coolie with respect to W weight is 0, because force and distance F dot D cos 90 will be 0. But work done by coolie with respect to friction is not equal to 0. This is the catch here. This is the catch that you might be not knowing. That is why I told you that 90% people will be telling answer as 0. And if this question comes in MSQ, 0, second option non-zero, C option, any other, all of these or any other option, guys, you might be wrong. You are only clicking the 0. But work done, you might be seeing in MSQ, this make option A is work done by the force is by the W weight is 0. You click it and move forward. But might be the C or B or D option might be the work done against friction, because here is the force and friction might be here. Then the angle is cos 180 and cos 180 is not 0. So how many of you have studied this concept first time? Please let me know with the heart sign on the comment box. Please let me know with the heart sign on the comment box if you got to this, because everybody knows this. Everybody knows this, but how many of you know this also? So please be aware of such MSQ questions. Why I am saying this? Abhinav Negi, why are you saying this? Because the IIT JEE examination, that is also made by the same IT professors. Same IT professors. Okay, might be not exactly the same of your branch, mechanical or civil, but by the same IT professor. They have taken this question in IIT JEE 2 years back. They have done this 2 years back. Okay. Now moving with the cross product. Cross product is force into distance P, the moment about A, P into D sine theta. That is again a vector quantity. Okay, it is given by right hand thumb rule. From P go to distance, and this thumb will be giving the direction of the vector product. Okay. Now moving further, suppose this is a pulley. Can you draw the, now I'm telling you the free body diagram. Okay, telling you the free body diagram. First of all, before the free body diagram, let me tell you the types of forces. Okay, Andhra Pradesh. Okay. Now let me tell you the types of forces. One is the gravity force, mg. Okay. One is the contact force. The property of the contact force is always perpendicular to surface. Okay, it will be perpendicular to the surface. Tension force means, suppose tension force means, how I can tell you this? Yeah, like this is a SpiceJet tag. Okay, and if I'm pulling this string will be in tension. Okay, if some monkey or spider put a weight on this, so here it comes tension in this. Okay, and if it is in equilibrium, I'm repeating, if it is in equilibrium, then the downward force W should be equal to upward force tension. If that is the tension force. Okay, now spring force, F is equal to Kx. If I elongate the spring by X amount, the force required or generated will be F is equal to Kx, and apply force. Apply force means I am applying the force that may be perpendicular to a body, may be inclined to a body, may be tangential to a body. That is applied force. Okay, so these are the types of forces, and we have to make the free body diagram. Now guys, suppose I have to make the free body diagram of this body. This is suppose here A, and this is suppose here B, and it is pinned here. Now I want to draw the free body diagram. Of this. This is A and this is B. Now let me tell you, whatever written in English, leave this. Whatever written here in the English, leave this. Let me tell you my way of free body diagram. Everyone. Let me tell you my way of free body diagram. Please see. Guys, whenever I want to make the free body diagram, this is my way. No teacher has told me this when I was in school, and no book has written this. What is my way? That whatever body you want to make free body diagram, assume that you are that body. And when you assume yourself at that body, you might be feeling the forces much better way. Okay, suppose there are so many complex figures and you want to make the free body diagram of a center sphere in that system, then assume that you are the center sphere. And when you assume that you are that sphere at the center, then you might be able to better understand the contact forces. Okay, now here tell me the forces, please, everyone, on the comment box. This is a pulley and I want to know the forces here. Self weight will be there. There is self weight also. So self weight will be where? Everywhere. Guys, weight of this pulley will be everywhere, na? Weight of this pulley will be everywhere, na? Weight of this pulley will be everywhere. So there is a self weight. Self weight will be acting as a UDL. Self weight will be acting as a UDL. This red one is due to self weight. What are other forces? Please tell me. What are other forces? Now here there is a bucket of water. So it will be acting as a point load here. it will be acting as a point load here. Bucket of water of weight W. The weight is W here. Now let me tell you one more thing. No load is a point load in this universe. Like rigid body is an assumption. Like rigid body is an assumption because nobody is a perfect rigid body. Everyone displaces or relative position changes. Similarly in rigid body also. Similarly everybody there is a deformation. Might be that is not visible by your naked eyes. Okay. Now what are the other forces? It is pinned here. So pinned here. So here will be a vertical and might be horizontal forces. Might be horizontal forces. It may be there. And if it is here associated with this pulley and might be this also a crank is also here. Crank is also here. So this and due to that rotation like this. So might be some movement also may be coming or torque may be coming. Have you got it? Have you got it? Okay. Now these are the types of forces we have done. Gravity, contact force, tension. Okay, I have given all these examples. Okay, now what is the difference between movement and torque? What is the difference between movement and torque? Tell me. Let me tell you. Guys, if suppose this is a body, let me tell you. Okay. Now there are three axes here. These two which are passing through the body itself. Which are passing through the body itself. These are called as transverse axes. These are called as transverse axes which are passing through the body itself. And one is the axis which is perpendicular to the body. Which is perpendicular to the body. Okay. This is longitudinal axis. Okay. This is longitudinal axis. Movement about any movement, force into distance about transverse axis is called movement or bending movement. And any movement, torque is also a movement, but that is about the longitudinal axis. That is about the longitudinal axis. So if I apply a movement, force into distance about this body, that will be a torque. And if I apply a movement about this white one, here or here, that will be a bending movement. Have you got it? Have you got it? So suppose this is a nut and this is a longitudinal axis, which is, this longitudinal axis is the axis which is perpendicular to the plane here. Which is perpendicular to the plane here. And if I apply a movement about this point like this, if I apply movement of this of this nut about like this, which is perpendicular to this body like here, so that will be a torque. That will be a torque. Have you got it, everybody? Please let me know. Concentrate on this nut, and this axis is longitudinal axis for nut, because any axis which is perpendicular to the surface, that is longitudinal axis. And if I apply movement about this, like that will be a torque. Have you got it? Okay. Now couple and its magnitude, guys. Couple is what here? Couple is, suppose this is a P force. This is a P force, and the distance between these two forces, equal forces, equal and unlike. Okay, the word here is where it is. A couple is two equal forces which act in opposite direction, unlike. That is a couple. So the moment here will be P into L or P into L. Now the speciality that might be you don't know. That might be you don't know. Is that this movement PL will be about every point. About here, the movement is PL, because about here this force P will be zero movement and this P will be PL. Okay. Now about here this P will be passing from here, zero movement, this will be PL, and all will be clockwise. Now about center of mass, about center, yes, center, about center. So P into L by 2 of that green one and P into L by 2 of this one. This is also clockwise, this is also clockwise. So this is again PL. Now about at quarter span, about quarter span here. So this P, downward P will be P into 0.75 L and this P will be P into 0.25 L, both in the clockwise direction. So that will be again PL. So at every point it will be PL. That is the beauty of couple. Might be you not knowing this point. Any other moment like this one, Here about this point it will be p into x. About here this will be p into some different x. About this will be p into some different x. Have you got it? Have you got it? Please let me know on the comment section. Please let me know on the comment section. Everyone please. Okay. Now what is the principle of transmissibility? In a rigid body, if a body is assumed to be rigid, then if P is you are applying here, then here if the reaction is P, then at this line of action anywhere, if you apply P here also, the reaction will be same. If you apply P here also, the reaction will be same. Okay. Now this coplanar, non-coplanar, which all are acting on the same plane, okay, which are all acting on the same plane, like this is acting here, in this all are in same plane, coplanar. Okay, non-coplanar, one is acting here, one is acting here, and different plane. Okay, so these I will give you notes. Okay, no need to do here. Okay, this pin support will be your horizontal and vertical reaction, roller will be only vertical, fix will be vertical, horizontal, and movement will also be there. Okay. So you all know this. Okay, so no, I'm not wasting time here. Let's directly go to a beautiful numerical. Let me see who gives the answer first. Everyone, guys, complete engineering mechanics will be taught to you. Okay. Okay. Now all these squares are 3 into 3. All these squares are 3 into 3, and let me check who is the champion here. Champion of the champions. Everyone. We want to find the moment about O point. Okay. Now, suppose this is theta. So this is 3, this is 4, so this hypotenuse will be 5. So cos theta is 4 by 5 and sin theta perpendicular 3, hypotenuse 5. Okay. F1 value is 30. With F1 I just got a point. We are coming with Formula 1 marathon series. Let me tell you about the upcoming sessions, guys. With F1 I just got to a point. We are coming for the whole. See, where is that? We are with F1 se yaad aaya. Formula 1 session, guys. For civil and mechanical both, for everyone this Formula 1 will be there. And one prediction series will also be there, where we will be predicting some types of question. Okay. So let's come back to our part. Where is that part? So beautiful numerical here, this one. Let me check who can do this fastest. Yes, the super duper Sonu sir is here. Okay. So F1 कहाँ है भाई 30. F2 कितना है? F2 is 15. Oh my god, ऐसे बड़ा भी होता है? Oh wow. सेम पैसे में इतना बड़ा भी, अब छोटा भी हो रहा है यार. F2 is 15. Okay. F3 is 25 and F4 is 30. Okay. Now everyone, F3 के कंपोनेंट निकाल लेते हैं यार. F3 is the father. Let me find the 2 sons here, or 2 daughters, or 1 son and 1 daughter. Otherwise, if I take 2 sons, then many will say he is a gender biased person. Okay. So F3 component will be here is F3 cos theta. Cos theta is 4 by 5. So F3 25 into 4 by 5 will be 20. And F3 sin theta Sin theta is 3 by 5. So 3 by 5 will be 15. So now we don't have to see this. We can see these two, because either we see these or these two, because these two are equal to this. Okay. Okay. Sir, please conduct open channel flow marathon. Okay, स्वामी कर देंगे. Now, कर देंगे. Ready. Now, the moment about O. First of all, let me find the force. Or movement will be easy. I guess you might be seeing the movement will be easy. So let me find the movement first. Summation moment about O. So movement of F4 will be 0. 30 is passing through that point only. 30 is passing from that point only. F1, 30 into this anti-clockwise, let us take negative. This is how much? 3. 3, 3, 3, 9. 30 into 9. This 30 into 9. That will be minus. Okay. Now this F2. F2 will be clockwise. So clockwise will be plus 15 into, what is the perpendicular distance? 6. Okay. Everyone is in same unit centimeter. Okay. Now this 15 is passing to that point only. 15 is passing from that point only, 0. And this 20 will be again clockwise. 20 will be clockwise. So 20 into 9. 20 into 9. So 30 into 9 is 210. 180. And 15 into 6 is 13 into 9, 270. 270 and 90 plus 180. 270 is equal to 0. So movement will be 0. Now let us find the force. Of course, from option we don't have to find the force, because only one option there is 0. Other no option is 0. Now force. Summation of F about point O. So first of all, let me find the vertical reactions. 30. This horizontal. 30 and 20 downward. 30 and 20 downward. Okay. Horizontal force is 30 here, 15 there, and 15 there. 30 here, 15 there. Horizontal will be 0, but vertical will be 25 cos theta. Cos theta is F4 is how much? F4 is 20 yaar. This is 20 yaar. So vertical forces is summation of vertical is 0, 20 and 20 0, or horizontal 15, 15 and 30 0. So it is also 0 0. Nothing. Got it? और इसके जो हमारे ये गलती थी, that our गलती, why this गलती does not come here? Why that this गलती does not come here? Because F4 is not causing any movement. Okay, that will be 20 into 0. Okay, that is why it is multiplied by 0. That is why गलती is not coming. Okay, fire triangle session. All three faculties are going to, yes, complete engineering mechanics will be done, guys. And what are the upcoming sessions? आपके prediction series is there. Guys, for civil and mechanical both, for every subject from 21st. And one is F1, Formula 1 for every subject, guys, civil and mechanical. And one is math session will be on 22nd on app, and 27, 28, 29 will be on our channel. Okay, and mock tests will be there on 22nd and 26th. So upcoming there is so much. Let's move further now. और जिसने ये बता दिया ना, ये मार्कर भी नहीं चल रहा, माइक नीचे फंस रहा है, बहुत बेकार किस्मत है आज. ये देखो चल ही नहीं रहा है. Okay, now this question, who does fastest? What is my English here? Come on. Now this question, who do fastest? Okay, he will be the champion of this question. Okay, now the applied force is this, position of particle is this, the movement is, so movement is D cross F. So let I, J, K. What are the D components? Position vector 1, 2, 3. And what is the F component? 10, 2, minus 3. Let me check now. For I vector, minus 6 and this minus 6. So minus 12. And minus 12 is only here. So that is why we don't have to do further in examination. Now, J vector, kahan gaya? J vector will be minus, it is second position. So 1 into minus 3 and 10 into 3, minus 30. So minus 33 and plus, it is matching again. Then K, 2 into 1, minus 20. So K, 2 into 1, minus 20 will be minus 18. That will be the B option. Okay, further. ये देखो चल ही नहीं रहा है, ऐसे ही बेइज्जती कराता है लाइव क्लास में. Okay, this is a railway post. This is a railway post. And what is the magnitude of movement about O? What is the magnitude of movement about O? Please do it fast. About this point we have to find. And only force is this one. Unless mentioned in question, self weight should not be taken. Okay, AU student, are you enjoying this, guys? AU student, are you enjoying this? Please let me know. Keep sharing, guys, and subscribe the channel for more sessions. And guys, very congratulations and thanks for your love and support that we have reached 250,000 supporters. I'm saying subscribers. Okay. Now, guys, convert this 300 into horizontal and vertical component. Okay, what is the horizontal one? 300 cos 60. What is cos 60? What is cos 60? 1 by 2. So 300, 150. And this will be sin 60, root 3 by 2. Okay, 150 root 3. Now summation of movement about point O. Summation of movement about point O, that is 150 into 3.5, that is clockwise, and 150 into 150 into this clockwise, and 150 by root 3 into 1.5, it is again clockwise. Both are clockwise. So what is the value you are getting from here? What is the value? Are you getting this one? What are you getting this one? Okay, guys, complete engineering mechanics will be there. Abhishek Sahu, complete engineering mechanics will be there. Dheeraj sir will be coming. Yes, me, Sonu sir, Dheeraj sir, everyone is taking this. Now, guys, we draw the FBD of this. Whenever the FBD of anything is required, I told you about the contact forces. Contact forces are कहाँ गया? अरे कहाँ गया? Contact force, what I write? It is perpendicular to the surface. Contact forces are perpendicular to the surface. Okay, just this thing. So where this? So it is connecting here and here. So where the force will be here? Here. Where the force will be there? Where the force will be there? It is perpendicular like this. And one will be the weight also. Okay. So if this normal force N1 and N2 will be there. So if this body is in equilibrium, so N1 ka vertical component and N2 ka vertical component should be equal to W. And if this sphere is in equilibrium, then N1 ka horizontal component should be equal to N2 ka horizontal component in opposite direction to make it 0. Agree or not? Please let me know in the comment section, guys. Everyone. And guys, me and Dheeraj sir will be coming with one more session. Do and don'ts. Do and don'ts. Yes or no? Yes or no? Everyone. Okay, now this one, please. This one, please. Everyone. Contact force का simple सा फंडा है. Contact force का simple सा फंडा है. Contact force का simple सा फंडा है. It will be perpendicular to the contact. So here it will be like this. Okay, and there contact से perpendicular. Perpendicular will always pass from the center. Perpendicular will always pass from the center like this. And one will be the weight. Of course, summation vertical and horizontal will be 0. Now this one. FBD of this, if this I am saying as green ball, okay, and if this I am saying as yellow ball, okay. Now draw the free body diagram of this green separately, this green separately. Arre yaar. And where? And this yellow separately, and this different question. C, yellow separately. Now one will be the weight in both of these. One will be the weight. Have you done? Beautiful questions will be there, guys. Okay, another will be the contact force. So this green perpendicular always passes from the center. So here also perpendicular always passes from the center. N1, N2, normal force. This normal force will be here also, guys. If I'm 80 kg, and I'm putting 80 kg downward, so floor is also putting me 80 kg upward. Okay. Now here again it will be some N3. Now can you draw the free body diagram of this surface? Can you draw the free body diagram of this surface? What is the free body diagram of this surface? So this N1 will be here, so it will be pushing N1 here. Okay, this N3 will be here, so it will be pushing N3 here. Yes or no? Yes or no? Everybody on the comment box, give me yes or no. Everyone please. Everyone please. Okay. Now this is horizontal reaction will also be coming here. Okay. Now guys, there are three types of equilibrium. One is stable equilibrium, one is unstable, and one is neutral. Stable equilibrium is this. Stable equilibrium is this. Okay, if you put this ball here, then again it will come here. If you put this ball here, it will again come here. That is a stable. This is an unstable equilibrium. If you put ball here, it will fall away. If you put ball here, it will fall away here. And this is a neutral. If you put here, it will be here. If you put here, it will be here. If you put, it will be here. Stable means it attains a particular position. Unstable means if you displace this, it will go somewhere else. Neutral means wherever you will put, it will be in equilibrium. Now, why this is important? Horizontal force for yellow. Horizontal force for yellow. N3, N2 component will be there, na? Oh, sorry. Yes, here it will be also here. Sorry. Now, kahan gaye? Now, guys, when I was in school or in first year of my college, I always think, okay, this is stable, this is unstable, this is neutral. Everyone can understand this from this figure, but what is the importance? Can you tell me the significance of this topic? Everybody knows that what is stable. Everybody knows what is unstable. Everybody knows what is neutral. Can you tell me the significance of this? Why we study this? What is the use of this? What is the application of this? Can you tell me? Can you tell me, guys? Can you tell me, guys? What is the significance? Nobody? No one? No one? No one out there? Let me tell you, the significance is this. Let me tell you, the significance is this, that whenever we are designing a ship, the ship always oscillates. The design of a ship should be like a stable equilibrium. Okay, कभी दिमाग में नहीं आया कि हम ये पढ़ते क्यों हैं? हम ये इसलिए पढ़ते हैं कि जब शिप होगा, शिप हमेशा एक पोजीशन में रहेगा. ड्यू टू वेव्स, शिप विल बी ऑसिलेटिंग. And if it is an unstable equilibrium, the designer has designed their unstable. So when ship is going here, it will fall away. When ship is going here, it will fall away. So ship we design like a stable equilibrium. If ship oscillates here, it will be fixed. Still it will be equilibrium. Got it? Got it, guys? Yes or no? Parallelogram I told you. Now what is Lami's theorem? If anything is in equilibrium, please see here. When three forces acting on a point are in equilibrium, then each force is proportional to the sign of angle between the other two forces. Like P upon sine alpha is equal to Q upon sine Q gamma is equal to R upon sine beta. This is only possible when the body is in equilibrium. Okay, like this. Now, can you just apply your GK, yaar? Apply your GK. You want to apply GK, common sense? From two things this question can be answered. One question is from IQ and another you can solve from formula. Your wish. Your wish. Your wish. Completely your wish from which you want to solve this. Either you can use IQ or you can use formula, your pen, your life, your rules. Absolutely your choice. Everyone, please let me know this. Okay. Guys, see. 2 and 2. Let me first of all use IQ. Let me first of all use IQ. Then 2 and 2 are the two vectors when they will be most, what is the maximum sum? What is the maximum sum? When they will be collinear. Okay? Guys, when me and my friend will do a business to the maximum, when our both orientation is in same direction. Might be my orientation is towards hard work, towards business, but his orientation might be towards girl or gambling, any other thing. So both orientation should be same, then the resultant summation will be maximum. Okay? So here it will be 4 and minimum will be when they are cancelling each other like this. Like in Mahabharat, the arrow of Ram and arrow of Ram and arrow of Meghnath, both are cancelling each other. Opposite. So it will be 0. 0 to 4. This is from IQ. This answer, the maximum will be 4 or minimum will be 0, is from IQ. Now if you want this from formula, see what is happening with me. Now if this one formula, this you want from formula. So resultant force is 2 F1 square plus F2 square plus 2 into 2PQ into cos theta. So what is the maximum? What is the maximum value of cos theta? So maximum value of cos theta is 1. Maximum value of cos theta is 1. So 4 plus 8, that is 16. So maximum FR max is equal to 4. Got it? And minimum value of cos theta is minus 1. So 4 plus 4 is 8 and 8 and minus 8 will be 0. F minimum will be 0. So 0 to 4. Which one of the following of the concurrent forces cannot have a resultant force? This can have. This can have. Have you understood? Let me take one more. IQ and concept both. First of all, I am giving you IQ. 2 here, 4 here. So resultant will be 6 maximum. And minimum will be 2 here and 4 here. Minus 2 or magnitude wise you can say 2. This from IQ. And from formula. Formula is also IQ here. Formula is also IQ. 2 square plus 4 square plus 2 into 4 into 2 into cos theta. So maximum value of cos theta is 1. So 4 plus 16. 4 plus 16 is how much? 24. Plus 16. No. 16 plus 4, 20. And here also 16. Maximum value cos theta is 1. So under root 36. Under root 36 is maximum is 6. Maximum is 6. Similarly, you can find minimum also. Similarly, you can find the minimum value also. Like 20 and this cos theta will be minus 1. Cos theta will be minus 1. Okay, so 16 and 4, 20. 20 and minus 16, 4. And root will be 2. Have you got it now? Please put a heart sign on the comment section. Please put a heart sign on the comment section. Similarly, you can find this. So this will go from IQ, let us go 10 to 8. Okay, this will go from 8 to 4. 8 to 4. 8 to 4. 6 to 2. 0 to 4. So this is only option. Maximum here will be 8. And minimum here, maximum will be 10, minimum will be 8. So this cannot have. Have you understood this question? Have you understood this question? Now P plus Q is equal to R. Also P is equal to Q is equal to R. The angle between P and Q is, P plus Q is how much? Resultant is how much? P square plus Q square plus 2PQ cos theta. Squaring. R square is equal to P square plus Q square plus square of this 2PQ cos theta. Okay, but all are same. Okay, all are same. So this can be also written as P square. Okay, Q is also P, so this can be also written as P square. 2P and Q both are same, 2P square cos theta. So from here, cos theta is equal to minus 1 by 2. So minus 1 by 2 theta will be whatever the value you are getting. cos theta is minus 1 by 2. So it will be 120. That will be this option. Have you understood this, guys? Now do this also from Lamis. I'm giving a hint. Do this from that. T2 upon sine of opposite angle. T1 is equal to sine of opposite angle. From there you will be getting this value. Okay. Okay, guys. So now Sonu sir, let me guys till then do this. Do this. Till then do this. Till then do this. Till then do this. Okay, Sonu sir will be ready after this question, guys. Sonu sir will be ready after this question. Now for minimum value of T2 for B in equilibrium. So T2 upon sine of opposite angle 60 and this is 90. So sine 150 is equal to T1 upon sine of opposite angle. This, what will be this? Or take it 500 now. Why to go in so much unknowns? Why to go in so much unknowns? So this is 500 and it will be sine 30 plus alpha. Opposite. Let me check who can do this fastest. Guys, we are coming with 22nd and 26th. 22nd and Republic Day with mega mock challenge. Mega mock challenge. Sorry, mock test live on YouTube for civil and mechanical both. And prediction series and another is the F1 series. Okay. Now T2 is equal to 500 into sine 150 upon sine 30 plus alpha. For T2 to be minimum, all these are constants. For T2 to be minimum, this should be maximum. T2 to be minimum, this should be maximum. Yes or no? Yes or no? So what should be the value of alpha? What should be the value of alpha? What should be the value of alpha? These are constant. Now से कोई फर्क नहीं पड़ रहा. For T2 to be minimum, this denominator should be maximum. So for alpha should be 60 degree. Alpha will be 60 degree. Yes or no? Yes or no? And guys, one more question now. One more question, that is my own question. My own question. Everyone. My own question. Now let only the student who can get a double digit rank. Who can get a double digit rank can answer this. Double digit ranker question. Double digit ranker question can only solve this. Let me check. If this is a string, now string has unit weight. String unit weight is equal to gamma and constant area. Constant area. And here is a monkey. Monkey of weight 35 kg. So where the tension will be maximum? Where the tension will be maximum? Only ready, please put this on my Telegram group, Civil by Abhinav Sir. I will answer you there. Please put this on my Telegram group, Civil by Abhinav Sir. I will answer you there. Okay. Tell me, no, where the tension in the string will be maximum? At L by 4, at B point, at A point, somewhere in the interior. Where T maximum? Double digit ranker question. No book has given this question. No book will be giving this question. This is my own frame. This is my own frame. A at B, B at C, all constant, D none of these. This is my own frame question. This is my own frame question. So guys, the maximum tension, we assume on an ideal condition, the tension everywhere is same. For ideal quotient, tension everywhere is same. But here I have mentioned that the string unit weight is lambda. That means the weight of string is also there. That means the weight of string is also there. And when weight of string is also there, guys, these all are carrying the load 35 kg of monkey. This all will be carrying the load 35 kg of monkey. But A point is also carrying the highest weight. Even this point is also carrying the weight of string. Even this point is also, but only this much. But A point, all these strings are carrying the weight of monkey. But A point will carrying the maximum weight of rope, also the full weight. Okay, B point is not carrying the weight of rope, only the monkey. Somewhere between only half length or partial length and weight of monkey. But A point will carrying the maximum weight in this. Have you got this? Everyone, please let me know on the comment section. Have you understood this, guys? Please let me know. So guys, let me tell you about very important upcoming sessions. One will be the prediction series. Here we will be coming with few questions. Okay, good AU. Few questions, and guys, this will be from 21st of January. Very important series for the GATE 2023 students. And guys, one is the F1 series also, where we are telling for every subject of civil and mechanical, we will be telling you the formula. Okay. Now, one is this session will coming on 20th. How to utilize the upcoming 20 days. And guys, mock test will be on 22nd and 26th of February. 22nd and 26th for civil and mechanical both. Okay, that is the assumption that all things are considered at center, but actually it is distributed the whole length, na? Aditya, that is the assumption. Okay, so that mock test will be on 22nd and 26th for both branches. Yes, Abhishek Sahu. Now guys, for this prediction series, I already told you, F1 series told you. Now this is the engineering mathematics session on 21st and 22nd at 10 AM by Rakesh sir and Ankit Joshi sir. This will be on app. Now guys, this is the non-tech marathon that we'll be having after the GATE examination. Okay, and guys, this is the 3 champions, 3 days. First, Richa ma'am will be coming on 27th for this verbal part. Then mathematics on 28th, that is Saturday, Ankit Joshi sir. Then 29th will be Joshi sir's aptitude. Friday, Saturday, Sunday, the complete marathon by the 3 champions. I hope guys you enjoyed this. And Dheeraj sir and I am also coming with do's and don'ts session. Okay, Dheeraj sir and me are coming on do and don't session. And also on 19th at 11 PM, 51 best PYQs for SOM. Okay, so now guys, within the next 2 seconds, I will be off from your screen and Sonu sir will be joining. Okay, after the next 2 seconds, I will be off from your screen and Sonu sir will be joining you all. Okay, so guys, thank you all. Take care, everyone, guys, and enjoy the complete mechanics marathon.
So very good evening to all of you. Before starting the session, just let me know, is my audio video clear or not? Good evening. Very important session related to force system and equilibrium, my dear. Sir has conducted. I hope you have got number of important things. After that, we are going to start most of the engineering mechanics part in this session. After this part, my dear, Dheeraj sir will be there. Okay, let me increase the voice as you have told me. Just a minute. Just give me 1 minute. Okay. Now is everything fine? Yes. Okay. Now I think it is good. Okay. Right. So chaliye, let's start the session. We are going to start. This is all about me. बहुत ज़्यादा देर नहीं रुकते हैं. Formula 1 series already detail has been given by Abhinav Sir. 21st will be the date, and lot of important things are yet to come for GATE 23. You need to wait. You just be on the channel, my dear. Lot of important thing you will get. Yes. prediction series. It will be also started from the same date. That will be 21st of Jan. Branch will be mechanical and civil. Yes. Entire PDF will be shared on our Telegram channel after the lecture. And sir, this is the list of the table. This is the list of all the chapters. First chapter is already covered. After me, Dheeraj sir will join. He is going to take the entire topic of the truss, my dear. After that, we are going to start it, the kinetic of rigid body, and one by one we are going to move in such a way. This is all. We are going to move forward. So let's start the topic with the rectilinear motion. Sir, in the static part we have already covered from Abhinav sir. If you will talk about the motion, my dear, then you may have the motion in two types. One, it may be the example of the 1D or simple the example of the rectilinear motion. Second, it will be the example of 2D. Let me draw a simple figure. If it is a particle, x and y is the direction, and if I will take the example like a plane, a particle is traveling in this direction. Can you please tell me, it is 1D or 2D, my dear? It is the example of 1D or 2D? Definitely most of you say, sir, it is the example of 1D. If the same particle is moving in this way, can you please tell me again it is 1D or 2D? Most of you say, sir, this one is the example of 1D. This one is also the example of 1D. At the same time, if I'll ask, if my particle is moving in this way, is it third one is the example of 1D or 2D? What do you say? In the motion, when body is displaced from one particular point, that is definitely a motion, and motion may be of two types. One is 1D motion, second is the 2D motion. I just want to ask, आपका इसमें क्या view है? What is the type of motion in third case, my dear? In third case, it is the 1D motion or 2D motion or 3D when the particle is moving in x and y axis. Yes, can you please write the answer? All of you, Ajay, Srot, Abhishek, what do you say? It's an example of 1D motion or the 2D motion. And right now, nowadays, the weightage of engineering mechanics is not low, because if you see the last year prediction or last year analysis of the GATE exam, near about 6 to 7 marks is asked related to the engineering mechanics. तो ऐसा नहीं कि अब बहुत कम marks का आ रहा है. It's not like the old engineering mechanics now. The subject want इज्जत, right? Okay. So one of you say, sir, it is the example of 1D. Anyone else? Ajay say it will be the example of 1D, my dear. Yes, definitely it is the example of 1D. Why it is the example of 1D? Because most of you think that, sir, when body is moving in the x direction, body is moving in the y direction, that is the 1D. But when it is moving in x and y direction, that is the 2D. No. Sir, in a single direction, body is also moving. That's why it is the example of 1D. So simply you can say the example of the rectilinear motion, my dear, is the example of 1D motion. Similarly, the example of the circular motion, if a particle is moving in such a manner, my dear, that is also the example of 2D. Example of the projectile motion is also the example of this 2D. And after that, if I'll talk about example of the rolling, can you please tell me, it is a combination of the rectilinear motion plus circulation motion? What do you think? It is the example of 1D or 2D? Rolling motion. What you say, my dear, example of the rolling, is it the example of 1D or 2D? What do you say? Basic definition, basic part we are not going to discuss. In this entire session, we are going to cover the procedure, how to solve a lot of numerical, how to solve the number of important number of important questions, either theoretical or numerical, because most of the things are directly related to the point. How can you solve the number of problems? Yes, if you are going to write the GATE exam, it is also the example of 2D. So, sir, one thing is very clear in this chapter of motion, that we are going to discuss, my dear, 3 types of motion. 3 types of motion we are going to discuss. Rectilinear motion we are starting with. After that we go to the circular motion, and after that we go with general plane motion. And in this way, my dear, these three topics will be covered and motion chapter will be over, or the kinematics of rigid body will be over. After that, Dheeraj sir will come and he will start the topic of truss. Clear to all? Good. AU student, you are the topper, you are the winner. I think that's why you say that my answer is right. Okay, yes, good. Sir, what is the rectilinear motion? Motion of a particle in a single straight line, simple sliding motion. If you are sliding over this floor, it is also the example of the horizontal motion. If you are sliding over the floor, it is also the example of horizontal motion. Even it is the particle, my dear, and particle is sliding over the horizontal motion. Yes, it is the example of simple sliding or the rectilinear motion. But if it is the example of wheel, my dear, if it is moving in the forward direction with rotation, then it is not the example of rectilinear motion. So the motion of a particle in a straight line is known as rectilinear motion. Linear motion is also called as rectilinear, is 1D motion we are going to start with, and after that it is using y one spatial dimension, either x, y or any other dimension. Like I can write like this as a q direction, this I will write like x, this I will write like also x. So in single direction you can just make your motion of a rectilinear. After that, whenever it is a motion, my dear, two important concepts are very well known to us. That one is the reference point from where every dimension, everything is checked. Means if it is the example of a bus, my dear, that is traveling somewhere like this. It is a bus, it is traveling in this direction, and you are standing somewhere here, and you are going to check the entire, or you are going to study of this entire bus. So this reference point is the most important thing, my dear, most important thing for you, because reference point is the point from which all the observation are taken, all the observation. And after that, frame of reference is also the important point. What is the frame of reference? There are two type of frame of reference where observer can lie, can sit. One frame of reference is known as inertial frame of reference, and second is known as non-inertial frame of reference. इसका मतलब when you sit, when you check, when you observe all the bodies by sitting in a frame of reference which is not accelerating, and second one, when you are sitting in a frame of reference which is accelerating with some acceleration, my dear. Okay. After that, sir, for example, already it was a question that what is the main important point, sir? Reference point, that is 0, 0, my dear, from where the position vector, the displacement and the distance are measured. Like this position vector. Position vector is nothing but it is going to define the position of an object with respect to source reference. For example, if you are the source reference somewhere here and the particle is here, then position vector is going to give you the idea कि आपका particle right now कहाँ पे है? Where is your particle? Okay. Definitely yes. Yes, yes. Okay. After that, after some time or some interval of time, your position of the particle reach somewhere here, that is the 2. Then again the position of the particle will be 2, and between these both the particle, you can say the point is known as displacement, my dear. What is the displacement? Displacement is a straight line motion between two particles or two position of the particle. Like if it is the position of R1 and this is the position R2, my dear, then displacement can be written position vector of R2 minus of position vector of R1. This will be very helpful when you will do the derivation, when the position vector is given and you want to find the rectilinear motion and all the points. After that, from the position vector, there is a one important points come in the mind, that one is the distance and second is the displacement. Sir, any one of you can tell me what is the difference between the distance and displacement? Sir, distance is the actual path traveled by you when you are moving from one point to another point. And displacement is the ideal or minimum path traveled by you when you will move from the initial state to the final state. Like if you are just traveling from your city to any other city like Delhi to Bombay, then if you will check the aerial view, this will show you the straight line. So the straight line from Bombay to Delhi, it is the displacement. But you know very well, due to the number of restriction, it is not possible to move from one position to second position in the straight line. This is a simple, what is the answer? Displacement. So in this case, the actual path traveled by you, like this way, whenever you want, actual path traveled by you, it is the example of the displacement, but in actual, ideal or the shortest distance traveled by you is known as the displacement. So can you please tell me, out of both the thing, in which direction is important? Displacement in the displacement direction important according to you, or the distance direction is important? What do you think? Direction will play a very important role to define the displacement or to define the distance when you will go. Because let me tell you, my dear, very good Ajay, because this is the displacement we have already written, my dear, displacement, okay, and this is the distance. Only Ajay is going to write the answer. In the displacement, direction is important. That's why, my dear, it is known as the vector quantity. Displacement is a vector quantity, whereas this one is a scalar quantity. Okay for you? Scalar quantity. Clear? Second point. Second important point is speed. From distance, we are making the speed. We are inducing the speed, because speed is nothing but it is the rate of distance covered per unit time. Like I will write that speed will be equal to ds over dt will be the speed, my dear. So again, can you tell me, this speed is coming from distance. If the distance is a scalar quantity, my dear friend, then what will be the value of the speed? If distance is the scalar quantity, what do you think why the speed is scalar or vector? Is it the scalar quantity or the vector quantity? What exactly do you feel? Definitely it's a scalar quantity. Yes. And velocity, from where it is coming? It is the rate of change of displacement per unit time. Oh, sorry, rate of displacement covered per unit time. Can I write that velocity can be written by ds, vector, my dear, divided by dt. And this one is the vector. So from here, velocity is a vector quantity. Velocity is the vector quantity that is represented by a straight line. That is coming from the straight line. Very good, AU student. Wonderful, great. And speed is a scalar quantity. Good. After that, what is the acceleration and deceleration? When your particle is moving from this particular position to the second particular position like this, then definitely there are two options. You can increase or decrease the velocity of this one object, or you can have the same velocity of this object. आप चाहो तो इसकी velocity बढ़ा सकते हो, नहीं चाहो तो constant रख सकते हो. So what is the acceleration? Acceleration is the rate of change of velocity of an object with respect to time. What is the meaning of it? That acceleration can be given by rate of change of velocity with respect to time. Again, it is coming from velocity. Can you please tell me acceleration, my dear? Acceleration is scalar or vector? Again, these all are the theoretical question may be asked. Scalar or vector? Again, definitely scalar. Oh, sorry. No, not at all. ये क्या लिख दिया? It want इज्जत again. Acceleration want respect. After that, What will be deceleration, my dear? That will be nothing but du by dt. What is the meaning of it? The meaning it, deceleration means your velocity is going to decrease with respect to time. For example, there are two important example we can take. Like one, और आई थिंक आपने एक वो यूट्यूब की वीडियो भी देखी होगी, एक कार को धक्का दे रहे होते हैं, देन अगेन आगे से आके एक स्टॉपर लगा देते हैं, तो दिस इज द ब्रेकिंग सिस्टम. So whenever you will apply the opposite force on the moving body, you are going to produce deceleration in the body, because you are going to apply the opposite force in the moving body which is already moving. But if you apply the force in the same direction of the motion, that will increase the velocity, that is the acceleration. So always you check whether force is applied in the direction of motion or in opposite direction of motion. When it is in the direction of motion, velocity will increase, this will be a acceleration. Force will be applied in the opposite direction of motion, velocity will decrease, it will be deceleration. Clear? After that, few important points are started from here, my dear. Sir, as per the Newton's second law of motion, if the force is applied on this body having the mass m, my dear, having the mass which are okay. Have you attended applied thermo marathon? Yes. One by one I am going to take, because tomorrow a very important topic for all the mechanical engineers, that is the Lagrange equation and virtual work topic, my dear, because nowadays questions are asked from the topics जिसको हम नहीं करके जाते हैं. तो one by one definitely once this engineering mechanics topic will be over, after that, my dear, I'll start the portion of applied thermodynamics. Don't worry. Sir, as per the Newton's second law of motion, can we write resulting force applied on the body will be equal to ma? Is it or not? Yes. So can I write what is this one, my dear? This one is the effect. Is it or not? And what is this one? Teju, are you there or not? This is the cause. Means whenever force will be applied on the body, then it will produce the acceleration in the body. No force, no acceleration. If you apply the force in opposite direction, yes, I got your point. I got your point, Vijay, because I have just given the same voting or same poll I have just arranged in the Telegram channel, and your first priority it was the Lagrange. That is the reason tomorrow I have just arranged. After that, I'll start the applied thermodynamics. That topic will be compressible flow, nozzle, after that compressor, and my dear steam turbine. Yes, I have conducted the poll because it was on your priority that you want Lagrange equation, and after that, my dear, few important point of the engineering mechanics on your priority. So let me tell you, tomorrow morning I have just arranged the one session. One more session I'll arrange in the same way for thermal also. Don't worry, come back. So, sir, in this case, I can easily write that acceleration is coming from force. Can you please tell me, my dear friend, that acceleration is coming from force? Are you not getting that acceleration is the function of force? Is it or not? Now, if I will talk about the force, then how you can apply the force? Can I say either in first condition, because the motion, because acceleration is what? Acceleration is the change of velocity. So if I know I control the acceleration, I'll control the entire motion. Are you getting my point? If I control the acceleration, I control the entire motion. I'll be able to know each and everything about the motion. Like in this case, I can simply say that acceleration is controlled by applied force. Champak, are you getting my point or not? Vijaya, AU student, are you feeling this point? That because rate of change of velocity is acceleration and velocity is rate of change of displacement. So are you not feeling acceleration is deciding everything? But acceleration is decided by force. Sasank, yes, acceleration is decided by force. So my point is this: if you are able to feel how many type of force can be applied during the motion of the body, my dear. Entire motion, rectilinear motion can be felt directly. Each and every numerical can be solved if you are able to feel how many type of force you can apply on the body or on the center of the body. Like one can be right in general condition, you can apply the force 0. You are not going to apply any force, but there is a motion. Yes, it is possible. It is impossible. Second, if you apply, my dear, constant force, the force is constant. Getting my point? And third, my dear, if you apply force, that is the variable. I think these three type of force we can apply. Only these three possibility are there. Either you can apply the force on moving body as a 0. Either you can, or you can apply the force on constant as a, or force may be variable. And according to these, all the possibility of application of the force. Sir, कहीं से कोई भी छोटे से दिमाग में किसी कोने में से आपके माइंड में आ रहा हो? नहीं सर, these three possibility are not only possible. I know one more possibility. Please write in the comment section. No sir, these three are not more than sufficient. I know one more possibility. Write in the comment section. I simply say force on the body may be 0. Force on the body may be constant, or it might be variable. Three conditions are there according to myself. But what do you think? Any additional condition do you know? जानोगे कहां से? यही तीन है. छोटे वाले चंपक आ जाओ वापस. Come back. Very nice. After that, so according to this, we are having the three important type of motion, my dear. Three important type of motion. One is uniform velocity motion. What is the meaning of it? Uniform velocity motion. What is the meaning? Sir, in this case, when the body is moving like this, body is in motion like this, and right now no force is applied on the body. No force is applied on the body. So when no force is applied on the body, can I write acceleration will be equal to F divided by m, no force 0. What is the value of the acceleration? Value of the acceleration is equal to dv by dt. Can I write dv by dt will be equal to v is equal to u is equal to constant. So what important concept you are getting from here, that sir, when force is 0, in that condition velocity will be uniform. Are you getting my point? And what is this value of v, my dear? V will be equal to ds over dt. Don't say no, we have right now study. Or ds, s will be equal to, my dear, u into dt. Are you feeling? This is the relationship between the velocity and, my dear friend, distance. Velocity and distance, this is the relationship between both. Tomato Singh बहुत late आए. Yes, but आ गए. Next. At the same time, same body is displaced like this, my dear friend. Sorry. Same body is having the motion in this way, my dear. Like this is a rectilinear motion. But right now force is constant. It is not variable. So can I write acceleration in this case? Can you please tell me? Acceleration in this case, it is also constant. Sir, we have already studied that dv over dt. Okay. dv over dt, very nice, is equal to a. Or dv will be equal to a into dt. A is constant. When the time was 0, velocity was u. When the time was t, velocity was v. Can we write v minus u is equal to at? Or can we write v is equal to u plus at? Are you aware with this point? That when you write v is equal to u plus at, this is valid only for one condition. AU student, can you tell me what is that condition? V is equal to u plus at. You have applied 100 of time, my dear, but this one is valid only for a particular point, particular condition, that applied force on the body must be constant. Are you getting? Applied force on the body must be constant, my dear. Good. Let's go with the second point. After that, can we write from here that yes, very good, very good, that V is also equal to ds over dt, my dear, or this value will be equal to u plus at, that will be equal to ds over dt, or ds will be equal to u is constant plus of at, a is also constant, into dt. Sir, if you will find the distance, when time was 0, displacement was 0. When time was t, displacement was s. Are you not able to find the value of us? It is equal to ut plus 1 by 2 at square. Means, let me tell you, this equation of displacement can never be applied everywhere. ऐसा नहीं कि जहां चाहो वहां लगा दो. This will be valid when applied force is constant, when acceleration is constant. Similarly, if I'll compare the equation 1 and 2, one more equation is coming, that v square is equal to u square plus of 2as, my dear, sorry, 2as. Like this, okay? V square is equal to u square plus of 2as, right? After that, there is also one more condition. When the constant deceleration means a will be minus, but when the third condition is variable acceleration, not constant, it will be variable acceleration, then what will happen, my dear? Because in the constant acceleration, nothing will change, a will be replaced by minus a. That's all. After that, sir, if this is the body and the force is applied on this body, that is the variable. It is not constant, it is variable, my dear. Variable means function of time. With respect to time, every second force is going to change on the body which is under the motion. So in this case, what is the value of applied force? M into A. Can you please tell me what is the value of A? It will be equal to F by M. So F is variable, A is also the function of time, and that will be given like this. Function of time. Are you getting my point? And in this case, so V can be written by directly ut. Yes, it will be equal to u plus of integration of a into dt. Time will start from 0 to t. And let me tell you, my dear, in this case, when a will be given, deceleration is non-uniform. Is non-uniform acceleration? No. Vinay, my dear, deceleration may be uniform or non-uniform. Deceleration means you are going to apply the force in the opposite direction of motion. Getting my point? As the acceleration is a general term, that you are accelerating or you are increasing the velocity, deceleration is decreasing the velocity. But the numerical value of the acceleration may be 0, may be constant, may be variable. Similarly, numerical value of the deceleration will also be 0, maybe 0, maybe constant, or maybe variable. What is the difference between acceleration and deceleration? Numerical value of acceleration is positive and numerical value of deceleration will be negative. But all these two values may be 0, constant, and variable. If deceleration with negative sign, they will come. If acceleration with positive sign, they will come, my dear. Are you getting my point? अगर acceleration है तो हर जगह प्लस साइन के साथ आएगा, deceleration है हर जगह माइनस साइन के साथ आएगा, and both can have the 3 different condition. Getting my point now? Both can have the 3 important condition for you, my dear. 1, 0, constant, and variable. All the other point we have discussed, Now we are coming for the third point, that is variable point, my dear. So from here we have written the variable point. After that, sir, what is the value of v? We have already written v will be equal to ds over dt, if I'm not wrong. After that I can write ds will be equal to v into dt, or s ds will be equal to, substitute the value of this one, u plus of a into dt, 0 to t, my dear, and this will be equal to dt. So when this t was 0, distance was also 0. When time was t, distance was s, my dear. So from here s can be written as integration of u plus integration of a into d, 0 to t, my dear, and after that it is dt, and this integration from 0 to t. So you must think that this is the overall equation of the displacement and the velocity, my dear, in general. But by assuming the special case, by just assuming the special case, you are just modifying each and every equation. ये basic equation है आपकी. Whenever acceleration will be 0, then v will be equal to u. Whenever acceleration will be constant, then u will be out of the integration. Integration of this term will be t only. So all other terms are the special case of these two equations. Like when this term will be 0, then s will be equal to ut. Getting my point? All these three terms, whatever we have discussed in the previous one, these are the special case. Good. Variable deceleration, non-uniform, we are talking about this, we have already discussed. After that, sir, procedure to solve any numerical problem related to the Newton's second law of motion in rectilinear. Because after discussing each and every point, I am here to discuss the procedure also, so that you will never make a single mistake to solve the problem. Sir, what you need to do in this case? First of all, if there is any body somewhere like this, okay, there is any body somewhere like this, so first you need to check all the unbalanced force in the direction of acceleration. For example, if the body is accelerating in this direction, so due to all the force, you need to check what is the resulting force, my dear. Okay, then write the effect of these unbalanced force, that is ma, and after that establish the relation H per NSL, means resulting force will be equal to m into acceleration, my dear. Resulting force will be equal to m into acceleration, and once this a will come, once this a will be there in the solution, my dear, I think we all are able to calculate any parameter, either related to velocity, related to displacement, or anything you want to calculate, you will be able to calculate this value. Yes or no? What do you say? Once acceleration must be known to us. Getting my point? So in the first case, you need to find what is the total value of the force that is acting on the body in the direction of acceleration. Getting? Good. Let's come to the problem first. This is the question for you guys. In ISRO, it was asked, my dear, in ISRO, it was asked, in a second, time is 1 second. A particle goes from point 1 to point 2, moving in a semicircular path as shown in the figure. Then what will be the magnitude of average velocity? Let's see how many of you have studied this point properly. What is the velocity for this entire problem? Let's see how many of you are getting the correct answer of this question, my dear friend. How many of you have covered everything properly? Okay, according to Vijaya, answer is A. AU student, answer is A. Very nice. Anyone else? Anyone else? A is the answer. A is the answer. A is the answer. Very good. You must be surprised to know that Answer is absolutely wrong. Maximum of you have selected the same answer, but it does not mean कि जो आंसर आपने लिखा है, जो मैक्सिमाइज आप लिख रहे हो, वही आंसर सही हो. सर, what is the point of velocity you have written? Velocity is displacement divided by time. Is it yes or no, my dear? Displacement divided by time is the velocity. Yes or no, my dear? Yes. After that, the point is started from here. Even after the moving, the point is reached at this point. So what is the displacement? Displacement is the straight line between both. That is 2, my dear. Divided by time is equal to 1 second. Answer is 2 meter per second. C answer. Vijaya, C is the correct answer. AU student. Yes. No. It's not 2 minutes. It's a 1 only. 1 second is there. C is the correct answer. Ajay, you have already written. I have checked already. Don't worry. Vijaya, answer ऐसे change करोगे तो कैसे चलेगा? चलिए. Let's move forward. After that, sir, there is also one more method to approach the same problem, to get the answer of the same problem. That is simply known as D'Alembert principle. So what is the D'Alembert principle? When the force is applied, unbalanced force is applied in this direction, unbalanced force is applied in this direction, and due to this unbalanced force, my dear, acceleration is produced. Then if we add one imaginary force, one pseudo force in the reverse direction, then, my dear, body under this pseudo force, under this resulting force, will be in dynamic equilibrium. This is the D'Alembert principle. What is the meaning of it? If the body is in acceleration under the action of force, then the total summation of the resultant and the inertia force will be 0. It means body will be in dynamic equilibrium under the all forces with combination of the inertia force, with combination of the inertia force, like this, my dear, like this. Okay. After that, we can simply write that if the body of mass m accelerate with a rightward within the acceleration a, then there is the resulting force, that Fr is equal to ma, that will acting rightward in the direction of right. At the same time, if I will add one more that force, that is Fi is equal to ma in the leftward, inertia force acting leftward at the center of the gravity of the body, then it will bring the entire body in the dynamic equilibrium. Now, ये सारा statement आपने सुन लिया. These all are the books language. Now come to the main points. What is the meaning of it? As per the D'Alembert principle, you can solve any problem of dynamic with the concept of static. नहीं समझ आया, वापस आ जाओ. Abhinav sir have told you very important, very beautiful concept regarding the equilibrium. Yes or no? Equilibrium. That if the body under the equilibrium condition under lot of important forces, then sigma h will be 0, sigma vertical will be 0, and sigma moment will be 0. So what is the meaning of the D'Alembert principle? If you add one additional imaginary force in the opposite direction of acceleration, then body under all the applied force plus this imaginary pseudo force or the inertia force will be in dynamic equilibrium. What is the meaning of it? You can apply the concept of equilibrium equation, that sigma h is equal to 0, sigma v is equal to 0. Let's take one problem so that you will get the clear-cut idea from here. Sir, right now, the body is accelerating in this direction and under the force of F, under the force of Fr, my dear. Okay, Fr. What is accelerating? what you do, you apply one inertia force in this direction, Fi, my dear, Fi. Then under this inertia force and Fr force, body will be in equilibrium condition. So Fi is acting in the rightward direction, leftward, that's why minus. Fr is acting in the rightward, that's why plus. That will be equal to 0, my dear. That will be equal to 0. And what is the numerical value of Fi? Numerical value of Fi will be equal to Ma. Yes, that pseudo force will be numerically equal to m into acceleration. Numerical value of the pseudo force will be equal to m into acceleration. That will be equal to Fr, my dear. In this case, if I'll write, then Fr resulting force will be equal to Ma. This is the concept whatever we have derived from the Newton's second law of motion. This last point. The same concept you have also derived from the Newton's second law of motion. What is the meaning of it? That from the Newton's second law of motion, you can have one derivation. The same derivation you can prove with the concept of D'Alembert principle. D'Alembert principle, Newton's second law of motion can give you the same result, my dear. Same result आपको देते हैं, right? After that, let's try to discuss some important points, some important equations for the motion under the circle, or you can say circular motion. What is the circular motion? The motion of an object along the circumference of the circle is known as circular motion. What is the angular distance or the theta, my dear? The angle imparted, this particle, this entire rigid body is moving in this direction, my dear. Then at any time duration, the angle imparted by the point of the rigid body in the radial direction, it is known as angular distance. That is given by the theta. Its unit is theta, and my dear, unit is radian, and it is given by theta. Similarly, like displacement in the linear motion. After that, from the distance, let's move one step further. What is the angular velocity? Angular velocity, it is the rate of change of angle, like displacement per unit time. It is given by omega. Its unit is again d theta by dt. Similarly, angular acceleration, my dear, it is the rate of change of angular velocity. It is given by alpha, and its unit is d omega over dt. Are you not feeling something similarity? That if I will replace displacement by theta, velocity by omega, acceleration by alpha, force by torque, then I will have the same equation of the motion in circular case as we have discussed in the rectilinear. Are you feeling this point? आप क्या करो, सारे rectilinear के parameters को replace करना सीख जाओ. Like in this case, if it is the linear motion, my dear, linear motion, and in this case, this is the circular motion. This one is the circular motion. If the s of this replaced by theta, u of this replaced by omega 1, v of this replaced by omega 2, and a of this replaced by alpha, mass of this replaced by mass moment of inertia. With this one, my dear, force in linear motion is replaced by torque, and kinetic energy of the linear motion, what is the value? 1 by 2 mv square. This will be equal to kinetic energy of the circular motion, 1 by 2 I omega square. Are you not getting some similarity? So by replacing these important parameters, you can derive the same equation for the circular motion also. Like in this case, theta can be simply written as omega t plus of 1 by 2 alpha t square. Omega 2 can be written as omega 1 plus of alpha t. My dear, omega 2 square will be equal to omega 1 square plus of 2 alpha into theta. when in this case alpha is constant. And alpha is coming from, can you please tell me from where this alpha is coming? Like T by I, whatever you have discussed. Similarly, I am going to discuss in circular motion also. Alpha will be calculated from the numerical value of T divided by I. I is the mass moment of inertia, my dear. Clear to all? These are the all equation of the circular motion I have derived for one type of motion, but I am very sure that you will be able to derive all the equation in the similar way as we have written in the rectilinear condition, because only the notation, only the parameters are changing, no concept is changing in this case. Getting my point? Good. Let's move forward, and after that let's check whenever body or the points in a circular motion are moving from one particular point to another particular point, my dear. Like मैं थोड़ा साइड हो जाता हूं so that आपको अच्छे से दिखे ये. If this point number A or the P, my dear, if it is moving from this particular point to this particular point, that is P dash, can we write there is also one straight line? Straight line is there, linear displacement is there. Linear displacement is there, linear velocity is there. Are you getting my point? So if a particle is moving in the circular motion, my dear, if the particle is moving in the circular motion, okay, और रात में बहुत ही कम बच्चे जगते हैं ना, क्योंकि इस समय वही जग रहे हैं जिनको रैंक लानी है. आधे से ज्यादा इस टाइम तक आते आते उम्मीद छोड़ देते हैं कि रन तो हमसे ना हो पाए, राइट ना. तो आ जाओ वापस. सो in this case we can write the resultant velocity can be given by this omega r. Direction will be tangent, my dear, tangential, and total acceleration or the resultant acceleration will be given by vector summation of tangent plus vector summation of radial, where the tangent component can be given by alpha. What is the alpha, sir? Angular acceleration. And radial component can be given by omega square r. So if it is the body, my dear, then on this particular point there are two important acceleration working right now. If it is rotating, this is alpha r, one acceleration tangent, and there is also one radial component, that is omega square r. Are you getting my point? Two acceleration are acting. One is tangent acceleration and second one is the radial acceleration. And due to these two acceleration, my dear, these two acceleration, two force are coming. That one is known as centripetal force, that is equal to m alpha r, m omega square r, or it can be written by m v square r divided by r if I substitute the value of omega in the term of v. Similarly, this value of the radial centripetal force means radial force. This is also known as centripetal force, not centrifugal. Centrifugal is just an inertia force, opposite of it. And second is the tangential force, that will be given by m alpha r, that is the tangent force, my dear. Tangent force. Do you know why this alpha is changing? Sir, in general way you have studied that there are two type of acceleration. There is one type of acceleration, that rate of change of velocity is known as acceleration. But why in this case two acceleration are coming? In the circular case, one radial acceleration is coming, but at the same time, my dear, one more acceleration is coming, that is known as tangential acceleration. Tangential acceleration, okay, you can say, sir, this is coming due to the change of magnitude of velocity. Because velocity, if it is going to change, then definitely it is coming. But why it is coming, my dear? omega square r when it was the rectilinear motion, you have never written two acceleration. कभी नहीं लिखे ऐसे, लिखे थे कहीं? Only one acceleration. dv over dt will be the acceleration. But in this case, you are writing two acceleration. One is radial, second is tangential. What is the reason behind it? Because tangential acceleration is going to give you the rate of change of magnitude of the velocity, but this is going to tell you due to change of direction of the velocity. Getting my point? Because acceleration is the vector quantity, and every vector quantity will be present, every vector quantity will be there, either magnitude or direction or both will change, my dear. And in this case, this omega may change. If omega may change, then definitely magnitude is changing. And even this omega will not change. Till that, my dear, your direction will change every second. Because theta is going to rotate after each and every second. So direction is changing after each second. Either omega magnitude change or not, my dear. Getting my point? Yes. Okay. Good. After that, there is one motion that is known as circular motion. Circular motion in the vertical plane. Sir, before starting this motion, I'll just ask a question. 26 or 27, you are there in the comment section. कभी आपने बचपन में, in your childhood, have you play a game? There is one stone, you have just tie this stone with the help of a thread or some rope, and then you start to rotate this stone in the vertical plane. Anyone? Have you seen like this? कभी मतलब देखा तो क्या? Have you played like this in your childhood? Then and only then your childhood was awesome. कभी पत्थर बांध के रस्सी से उसको चारों तरफ घुमाते थे सर के. Anyone? Yes, very good, Vinay. Are you able to remind this point? Sometime the same stone come on your head, ऊपर से सीधा नीचे सर पे गिरता था. किसी के साथ हुआ है ऐसा? एयू, विजया, अजय, विनय, एनी वन ऑफ यू, किसी के साथ ऐसा हुआ कि ऊपर से आके सीधा सर पे गिरा? कई बार तो पता चल रहा है डॉक्टर के पास जाना पड़ रहा है. यू गो टू द डॉक्टर, बोले सर खून ही खून हो गया है. यस, एनी वन? नो, किसी के साथ नहीं हुआ. वेरी गुड. इट मीन्स आपका चाइल्डहुड ऐसा नहीं हुआ. योर चाइल्डहुड वाज नॉट ऑसम. गुड. कम बैक टू द पॉइंट. डोंट टेक इट सीरियस. सर, हियर टुडे इन दिस लेक्चर, माय डियर, yes, मेरे साथ हुआ. वेरी गुड. At least any one of you have the experience that you can say, sir, my childhood was awesome. Okay, good. So from this topic, my dear, if you are the one जिसके साथ ऐसा हुआ है, it means you need to study the mechanics. और जिसके साथ नहीं हुआ है, आप ये मान के चलो कि आप बचपन से मैकेनिक्स जानते थे. मतलब in the first class, even not in the first class, before the first class, you have before the nursery or KG, you were very well aware with the all concept of the mechanics, my dear. सारे concept आपको आते थे सबसे. अगर आपके साथ नहीं हुआ है तो come back to the point, sir. In this circular motion, you know very well, there are always two forces apply on the body. हमेशा दो forces होंगे. One, because you are here and the string is connected with this stone, my dear, and this is the stone. Stone is rotating in this vertical plane. Now, if it is a string and you are somewhere here, my dear, then definitely there will be a tension in the string. Yes, there will be a tension in the string. At this position, tension will be in this direction. But at the same time, to balance all the acceleration, we have discussed, Srut, to balance all these acceleration, one pseudo force or inertia force come into the picture. What is that pseudo force? My dear, that pseudo force is known as centrifugal force. Centrifugal force is the pseudo force. You have written a D'Alembert principle. Centrifugal force is the pseudo force that is maintaining the equilibrium condition under load of acceleration, my dear. So, if I'll write in this case, sir, if the body is going to rotate in this direction with variable omega, in this case, so the tension at this point will be acting in this direction. In this direction, there is also the acceleration, my dear. Yes or no? Radial acceleration will be there. And if the radial acceleration will be there, then definitely centrifugal force will come into the picture. Centrifugal force will come into the picture to balance it. Is it or not? So under H per the D'Alembert principle at point A, my dear, and yes, there is mass, then mg force is also acting. So mg force is also acting in downward direction. Good. Now let me tell you, at point A, my dear, three forces are acting on the body. One, mg in downward direction. Yes or no? Second, tension in upward direction. And third, my dear, centrifugal force to balance all the thing. And under these all the three forces, as per D'Alembert principle, body under the dynamic equilibrium is there. Right? Can I write? At point A, my dear, can I write TA upward must balance mg plus of, yes, truth. What is the centrifugal or centripetal force? Let me tell you. Sir, we have already discussed. I think आप थे नहीं वहाँ पे उस time. Sruth, I've already discussed. Whenever any type of or any kind of acceleration is there at any point, then definitely it is developed due to some force. So when you say in the previous case, my dear, if the radial acceleration is developed in this case in the downward or the center towards the center, then definitely this is developed due to one force, and that force is the centripetal force. Are you getting my point? Centripetal force. But as per the D'Alembert principle, we have also discussed that to balance all the unbalanced condition, there is one pseudo or the inertia force you can add, that is the centrifugal force. So in this case, I have added this one, my dear. Fc is a centrifugal force, and under this centrifugal force, my entire body or the system is in equilibrium condition. Like TA is acting upward is equal to mg plus of centrifugal force. So in this case, I will say that tension at point A will be equal to mg plus of mv a square divided by r, my dear. If the r is radius. Similarly, if I'll apply one more concept at point B, my dear, when the ball is reaching or your stone is reaching at point B, B for Bombay, my dear, right now your ball is somewhere here. Like this. Can you please tell me in which direction mg will act? Always mg will act in downward direction. Is it or not, my dear? In which direction tension will act? Tension will also act in this direction, TB. In which direction centrifugal force will act? Always out of the body, out of this circle, my dear. Can we write like this? So again at point B, if I apply the D'Alembert principle, can I write TB, my dear, plus of mg will be equal to Fc at B, or TB will be equal to, my dear, m velocity of v square divided by r minus of mg. The main problem is this one. Main problem is this one. Whatever derivation you have done, my dear, whatever drive you are able to feel from here. अब जरा सोचो, if this tension is positive, there is no issue. Means if the tension is positive, your string is tight. If your tension becomes zero, by any mistake you do at B point, my dear, are you not feeling? At that time, if the tension is zero, then your string, your wire, your rope will be loose because there is no tension in it. Directly stone will not come on your head. Are you getting my point or not? ये वो condition थी. So if you want that your tension must be positive, greater than zero, then the minimum value if I'll balance, then my dear mvb square divided by r minus of mg, my dear friend, must be greater than or equal to 0. This is the minimum value we should decide. Then velocity of v should be greater than or equal to under root of gr, my dear. If we calculate, what we are getting, the important concept, that minimum velocity at top, at this point, we top, minimum velocity should be under root gr. What is the meaning of it? If you are having the velocity at top less than this, directly stone will come on your head. यही वो पॉइंट था जिसके सर पे नहीं गिरा. It means you have already studied all the concept of engineering mechanics before the nursery class, first or second class. Minimum velocity at top must be under root gr. If it is less than this, then tension will be less than 0 or equal to 0. Then definitely, my dear, your complete stone will come on your head. सीधा सर पे आगे गिरेगा. खेल लेना फिर मजे से. Are you feeling? If you will rotate, means if it is more than this, it's not an issue. Under root gr, if your velocity is more than under root gr, then it is not an issue. But if it is less than under root gr, there is the issue. Getting? Good. Good. In the same way, you can calculate the value of velocity or the tension at all the point, whatever you want to do. जहां पे आप चाहो वहां पे इसकी टेंशन आ सकती है. Do you want? Yes, you can calculate if you are able to draw all the centrifugal force and all the tension, my dear. Good. Let's solve some questions. Let's solve some question. A car of mass mg is moving with a circular path at a radius of r as shown in the figure. What should be the velocity at this point, my dear? This point. What should be the velocity at point A? Yes. Rohan. Okay. Okay, in place of car, sir put stone. अब तो कहां से लाएं यार इसको, रोहन? Yes. Anyway, write the correct answer. C is the answer according to Manas. Anyone else? C is the answer according to Vinay. Ron, what do you think? Correct answer of this question. At this A point, my dear, I just want to calculate what should be the minimum velocity so that at this particular point, it will reach at this point. Are you getting why, sir? Reason is very clear. Sir, at this particular point of V, I want minimum velocity as under root 2gr. Under root gr. So at this point, if I require under root gr, then you need to calculate, sir, what will be the velocity at this point? Can I write, sir, this point is located at a particular height. That's why it will have one kinetic energy plus it will have one potential energy. And as per the conservation law of energy, I will write total energy at B must be equal to total energy at A. Yes or no? This will be the concept. So you know the velocity of this point, you want to know the velocity of A point. So we can write 1 by 2 m velocity of V is equal to under root g r square plus of mg 2r, my dear, 2r na. From here, if I'll take this as a datum line, so this is 2r mgh, like this, will be equal to, but at this point A, only kinetic energy will be there, that is velocity of A square. So m and m will get cancelled. This will be equal to gr divided by 2 plus of 2gr. This will be equal to va square divided by 2. So if I solve, what is the velocity at A? You all are getting under root 5gr is the answer. Excellent, my dear. Very nice. Maximum of you have written the answer. Maximum of you. Good evening. Good evening. Yes. Very good evening. Wonderful. Maximum of you have selected C as a correct answer from this circular motion, my dear. Yes, yes. Sure. Bilkul. Free education mission. Definitely. Yes. After that, let's come to a circular path. Sir, what is the difference between the circular path and curvilinear? Sorry, let's come to the curvilinear path. Till now, we have discussed two important topics. One is the rectilinear motion, complete my dear. Second is the circular motion, complete my dear. After that we are going to discuss curvilinear motion. Sir, what is the difference between the curvilinear motion and the circular motion? Let me derive from here. Sir, in the circular motion, body will rotate about a point. Good. But in curvilinear motion, body will be the combination of both. Separately, combination of both separately means for some time it can have circular motion. After traveling some distance, it can be having the rectilinear motion. After that, वो आपने कभी गेम खेला, वो कौन सा गेम है, the racing game, I think Climb Hill or something like this. Yes, in that portion you have seen sometime it is the curvilinear circular path, after that is straight, after that circular. Like if you will check this motion now, then up to this my dear, it is definitely a circular motion. But after this is the straight line motion. After that there is a circular path. Yes, hill climb, exactly, F1 racing you can say. So in this portion, when this sequence is given, are you not feeling, are you not feeling in this portion my dear, that is the straight line motion? Is it or not? What do you say? It is not the straight line motion? Yes or no? Yes. And in this case my dear, this one is okay. The game का नाम लिखा, लग रहा है सारा एकदम दिल की बातें बाहर निकल आई हैं. We want this. आप सर डिस्कशन ही इस तरह के करो. Okay, come back. After that, it is the circular motion. Good. So, one is the circular motion, one is the straight line motion. Let me tell you, in this case, nothing additional is required to study this topic my dear, or the curvilinear path. The point is, whenever the motion is circular, you apply the concept of a circular path. Whenever the motion is a straight line, you apply the concept of a straight line. That's all. Are you getting my point? In general case, I can simply write that average velocity of the particle from here. If I discuss, then simply I can write, can you please tell me what is the total acceleration on the curvilinear path my dear? If I'll write, because once curvilinear path acceleration is decided, after that you will be able to write everything. In this case, if I'll write the total acceleration, what is it? It is the tangential acceleration plus of normal acceleration. So normal acceleration is just like a radial acceleration, because always no radial motion is there. So in this case we can write that total acceleration. In this case, what is the tangential acceleration? Already we have written rate of change of velocity is the linear acceleration. Yes or no? That will act in tangent direction, plus or what is the normal acceleration we have written my dear? V square divided by r, that will act in radial direction. Is it or not? Now for the straight line motion, my dear, can you please tell me, this component is coming from, in the circular path, this component was coming from due to the change of direction. Is it or not? Due to the change of direction. Is it change of direction of motion my dear? Yes or no? And this is coming from due to the change of magnitude. Due to the change of magnitude my dear. Very important concept we are going to discuss here. Can you please tell me, in this case, when the line will be the straight line, like in this case, in this motion my dear, in this part, can you please tell me what is the change of direction? In this straight line, what is the change of direction? What is the change of direction? What is the change of the direction in this path my dear? Straight line. Is it any possibility to change the direction of the motion? What do you really feel in this case? क्या straight line में direction change possible है? Not at all. Is it? कुछ तो लिखो. Write something in the comment section. Okay, no change. So no change means in that condition, can we write that total acceleration, my dear, can be written as only the rate of change of magnitude of velocity. Only the magnitude, not direction, sorry. Not direction. We are not going to represent the vector. And that direction will act in tangent. That is the difference. Where the circular motion will come, apply the first equation. So this is the equation for the first one, my dear, and this is the equation for the second one. Is it or not? First one, second one. Equation of a circular motion, equation of this rate of change of magnitude in the straight line condition. Okay. After that, third motion we are going through. After that, Dheeraj sir will join and he will be discussing the topic of truss, most important topic for all of you guys. Truss topic is one of the important topic for the gate. After this general plane motion, sir will come and he is going to discuss a very important topic related to engineering mechanics, truss. Very important topic for all the mechanical and the civil engineers, my dear. Yes. So, in the dynamic portion, I am coming on the screw jack. Yes. After that, I'll again come back and I'll start the topic of friction, then kinetic of rigid body, then application of the friction, then my dear CG and moment of inertia, Lagrange, all the thing I'm here to discuss. First of all, let's come to the truss topic that will be discussed by Dheeraj sir after the completion of general plane motion. Yes, don't worry. Okay, don't worry. Come back. Sir, what is the general plane motion? General plane motion. So one by one you need to cover each and everything, because let me tell you, most of the time, my dear, you feel that in the engineering mechanics topic, there is nothing to study. कुछ है नहीं स्टडी करने के लिए. And most of the time you start to think, sir, क्वेश्चन तो इतने ज्यादा आते नहीं है. Do we really focus on this part? But let me tell you, in the last year, have you seen the scenario of EM? It was 7 marks. And 7 marks is a good, very good score out of 70 marks. I'm talking about the mechanical engineering. And out of 7 marks, my dear, all the topics were related to the 11th class mechanics. But the point is this, you don't know the procedure, how to approach. So what, after the truss topic, whenever these all the topic will be coming now, yes, don't worry. Whenever these all the topic will be coming, then we will covering each and every procedure, कैसे कैसे step by step बढ़ना है, कैसे कैसे problem solve करनी है, because engineering mechanics is not the subject of formula. Whatever, if I'll talk about the numerical formula, my dear, then 90% of formulas you are aware with. 10% of formula I have written hardly, otherwise 90% of formula you already know. But the point is how you will utilize this formula. What will be the condition when S is equal to ut plus 1 by 2, at square will be valid. If the acceleration is variable and you touch this formula S is equal to ut plus of 1 by 2 at square, you will get minus 2 by 3 marks. छूके देखो इस फॉर्मूले को वेरिएबल के कंडीशन में, you will get the answer. But till now, when the question related to motion is there, always there is only one equation, S is equal to ut plus 1 by 2 equation 1 by 2 at square solve, सब कुछ हो गया. ऐसा खेल नहीं है. Have you seen? There are 4 important conditions. Each condition having the 3 formulas. There are 12 to 13 formulas only to calculate the acceleration, displacement, and my dear friend, velocity. So procedure must be clear. Let's come to the point. Dheeraj sir is also in the comment section. After the session, my dear, after this portion, he is joining the session. You just make the heart sign for sir. He is going to discuss very important, very conceptual topic for the static portion, my dear. That is the truss. सबसे ज्यादा favorite topic for most of the engineers. Come back, sir. Now, what is the circular motion? So, circular motion in general, when the body is having the translation plus of rotational motion, then if it is the combination of translation and rotation, then it will be the example of general plane motion. And my dear, example is rolling on the horizontal surface. Rolling on the horizontal surface. Now question will be coming in your mind, sir, अगर यही था तो अभी तो curvilinear पढ़ा है. The same thing we have discussed the curvilinear. Sir, how will make the difference between the curvilinear and this rolling or the general plane motion? So my dear, yes, there is the difference. What is the difference? In curvilinear motion, rectilinear and circular, both the motion are separated. When rolling is there, a straight line is not there. When a straight line is there, rolling is not there. But in general plane motion, both are simultaneously. For example, if we'll talk about this point, my dear, if you talk about this point, like there are the number of points, like this one is A point, this one is B point, this one is C point. After some time, the location of this entire wheel is changed like this, that A is become A dash, then my dear C becomes C dash and B become B dash. So are you not feeling, if I will check the linear condition of C, linear condition of B and the linear condition of A, my dear, are they following the same distance? Are they following the same distance? Is it yes or no? No, sir. They are following same rectilinear distance, but after that, B is rotating about the, sorry, C is rotating about the B, A is rotating about the B. That's why with the rectilinear motion, they are also in rotation. They are also in circular motion. Are you getting this point? So when circular plus translation, both are simultaneously, these type of motions are known as, general plane motion or my dear rolling motion. Example is the example of rolling का example है. Are you getting this point? Is this point clear to all? Can you please write the answer in comment section? Is this point clear to all, my dear? Okay. So let's see what is the value of velocity of all the point. For example, if you are having a point on this particle P or in this body P, and this O is the point about which entire body is rotating, So in that case, if I'll check first of all, what is the total velocity of any point, that will be the velocity of the point about which entire body is rotating plus velocity of the point P under the rotation. Simply you can say it is the linear velocity of the point plus of rotational velocity of a point, but in vector form, my dear. Getting my point? Because body is having both the motion. So this is the condition of the linear velocity plus of the angular velocity or the rotational velocity. Okay. Getting? Okay. स्वयं भी बहुत है. आजो. Similarly, if I am talking about the acceleration, this will be the acceleration. That will be the linear acceleration, that is AO, plus of angular or the rotational acceleration of point P with respect to O. In this case, the translational acceleration will be given by similarly alpha with the I center. We can simply write, or we are covering the I center later on. First of all, let's discuss the I center point, my dear. What is the I center? So, to calculate the numerical value of the velocity, there are 2 points. One is the method of velocity of, or the relative velocity concept, and second is the eye center method. Sir, this one is a rigid body somewhere like this. This one, my dear, is a rigid body somewhere like this. Okay, somewhere like this. Like this, and all the particles are having the linear velocity like this. It is having the linear velocity like this. It is also having the linear velocity like this. Okay, after that, if I will draw a perpendicular line to this one, draw a perpendicular line to the velocity vector, that will be give you the eye center method. And what is the eye center method, my dear? Eye center is a center or a point when, बस आ रहे हैं after this topic, Dheeraj sir is joining to start the truss topic. Yes, when the body is in general plane motion, my dear, then eye center is a point where each and every point can be assumed under the rotation. Means what is the meaning of it? In actual condition, entire body is in general plane motion, but entire body in the general plane motion can be converted into the rotation. Converted into the rotation, my dear, when you apply the eye center method. But in this case, you must know only one thing. That thing is you must be able to know what is the eye center in a given problem. Like this is the RV, this is the value of RA, and this is the value of RC. So if this is the eye center, directly with the concept of rotation, velocity can be written by omega r, whatever you have written. So what is the meaning of it? If you are able to find the eye center, my dear, in the body, then from that eye center, you can rotate the entire system by considering that center as the center of the body. And after that, you can consider the rotation. Like if I will consider this as a circular body, my dear, circular body, and this one is a eye center. Okay, this one is a eye center. At this point, this is the eye center. Why this is the eye center? Because, sir, at this point, the velocity of this point will be 0, and entire body at the instant can be assumed to rotate about this point like this, about the eye point like this. So now each and every point on this wheel can be assumed under the rotation about this eye point, that is the point of contact. Even in actual condition, total wheel is in general plane motion. So if you want to know what is the velocity of this point, my dear, yes, exactly, AU, what is the velocity of this point? Directly you will write I R into omega 1. Omega 1 is this one, R1. Similarly, if you want to know the velocity, then draw a line, draw a perpendicular to this, that will be equal to velocity of this, that will be equal to omega into R2, because entire body is rotating like this. So in this case, what you have done, it is all about to consider, to assume the eye center where the velocity of the entire system becomes 0. So, or entire body can be assumed to rotate about this point. Let's come to the point. What is the meaning of eye center? It is the point in general plane motion whose velocity is momentarily is 0. At a moment velocity is 0. It is the point in the plane motion about which entire body which is in general plane motion can be assumed as in pure circular motion. And after that, if you are able to find the eye center, you will be able to solve the entire problem of general plane motion even with the concept of circular motion. Eye center has the 0 velocity but not the 0 acceleration. Why? Sir, every second eye center is changing its position. That's why in the starting velocity was 0, suddenly acceleration increase, it's changed its position. After that, velocity becomes 0. Okay. So eye center velocity is 0, but your acceleration is non-zero, my dear. Okay. So let's come to the numerical part. How many of you are able to write the answer of this question? It is up to you what concept you want to apply, you can. This is the gate problem, my dear. But how many of you are able to solve this problem? Yes. Anyone? What answer you all guys getting? There are two concepts. One is the concept of relative velocity, and second one is the concept of, my dear, eye center method. If you want to follow the eye center, it is okay. If you want to follow the method of relative velocity, then it is also okay. But what is the correct answer? A, B, C, D. A circular disc of radius R roll without slipping at the velocity of B. What is the magnitude of the velocity at point P? GATE का क्वेश्चन है. Okay, D is the answer according to Sri. Very good, Arvind. Maybe. Very good. It does not mean that your answer is right. Maybe right. We'll discuss later, my dear. Okay, A is the answer according to Vinay. Wonderful. It does not mean again that your answer is right. आपने answer दिया, that's why. Anyone else? Only two of you have written the answer. Okay, A answer, AU student, wonderful. A is the correct answer. Why? All the points are moving with the linear velocity of omega, like this. It means P point is also moving with the linear velocity V is equal to omega R, my dear. Let me move side. After that, due to rotation, because translation effect is there, due to rotation, it is also acting V is equal to omega R in rotation. This angle is 30, then what is this angle? 60, my dear. So if two vectors are acting in this way, what is the resultant value of this? We can simply write under root of omega R square plus of H per parallelogram theorem omega square in second direction plus of 2 omega R into omega R into cos 60. Cos 60 is 1 by 2. This and this will be cancelled out. So it will be equal to under root 3 into omega R, and my dear, velocity of point R will be equal to under root of 3 into omega R, that will act in this direction. Like this. This is the magnitude we have calculated. That's why we are not writing the direction. Is it clear where you have done the mistake? Is it clear, Arvind? Is your point clear where you have just made the mistake, my dear? Yes. Okay, Narayanan, very good evening. So A is the correct answer of this question. Yes. Yeah, point is P. By mistake, I have written point R. Sorry. Point is P, my dear. Point is P. So this is the numerical we have solved. Okay. This is the numerical we have solved based on the general plane motion, based on the rolling motion, my dear. Yes. Let me ask one more question to you. Can you please tell me the answer of this question? After that, after this question, Dheeraj sir is joining with the topic of truss, number of important concept. He is going to discuss related to truss. This is the question of the session. Let's see how many of you are getting the correct answer, my dear. From the point of rotation, linear velocity increase linearly under the rotation. Let me tell you. First of all, you need to find where the eye center will be there, my dear. Sir, if the eye center will be in middle, my dear friend, middle, exactly in middle, then upper part and lower part will have the same velocity, that is 2 meters per second. But upper part is having the more velocity. Then eye center, where this eye center will be located, this is the question. Sir, if I locate by this, then this one is 3 meters per second. And my dear, this one is only 2 meters per second. I think arrow is little bit somewhere like this. If I draw the diagram, no, not a straight line. If I draw the diagram, then diagram should be, yes, somewhere like this. This is the eye center where the velocity becomes 0. At this eye center, you can say entire velocity or entire body is rotating like this with omega, my dear, omega. So we can write from here that velocity of point P will be equal to omega into, my dear, IP, and velocity of Q will be equal to omega into, what is this value, QP, and this velocity of this 3, velocity of Q2, then IP divided by QP, my dear, it will be equal to 3 by 2, and IP plus of QP, it is QI, sorry, not P, QI, because it is the value of the I center. Yes. Into I. It will be equal to, what is the value? 200 mm. So what is the answer? 80 we are getting. Are you not getting 80? Bombay? Yes. Less than 100 we should get the answer. This numerical value we should know, my dear. ये value हमको चाहिए. Definitely you are getting the absolutely right answer. That is the 80 mm is the correct answer for this question, my dear. Yes. After that, welcome to Dheeraj sir in the session. This is just an information for you. Virtual work is going to 25 CTQ question. If you want to solve the virtual work related to Lagrange equation, tomorrow at 10 AM we'll be having. And after that, Dheeraj sir is coming. Sir, if you are ready, you just write in the comment section. And after that, friction and application of the friction I'm going to start after the completion of truss. Once like the session, my dear. And after that, welcome to Dheeraj sir. You sir, please write in the comment section. Is all good? If it is okay. Are you ready, sir? Yes, sir. Till now is everything okay? In the first part we have discussed, my dear. In the first part we have discussed the static portion. After that, okay. So Dheeraj sir is ready. I'll be see you again after that. So thank you all.
Yes, good evening guys to all of you. Please tell me, am I properly audible and visible to all of you or not? Then we are starting the session, guys. Yes. Good evening, Shruth. So we are starting the session, guys, now. And you know, I feel already Abhinav Sir have taken your equilibrium part, and then already one portion of dynamics part is taken by Sonu Sir. Now I would be coming for the topic trusses. Okay, I feel both mechanical and student guys would be knowing that one question is coming from the trusses every year. Yes. AU student Vinay, everyone, Ajay. Yes, good evening to all of you. So without wasting the time, we are starting the session. This is some detail about me, and today's topic is related to engineering mechanics. And guys, this is about some small announcement that from 21st of January we are having the new series for you. Okay, that is related to prediction series. Okay, and the second is in prediction series we are going to have like faculty wise question, like my top 10 questions for some subject. So that kind of session you will have. And after that you also have one more series that is related to Formula 1 marathon. Like in these marathon we are going to study the things in detail. There we will discuss only the formulas. Okay, so that series is also going to help you. And this is a mathematics marathon on 21st and 22nd January 10 AM for engineering mathematics. This is for 8 hours Maha marathon, but this time mathematics is not on YouTube. This is on the app. So be ready for this session. Okay, you can download the app for that. So guys, now we are starting the session, and the topic we are going to start is truss actually. And you know, every year questions are coming from the trusses. I will be going from very basic, and we will discuss everything. And also we will see some questions as well. So when we are talking about the trusses and frame, I would like to add one thing. Generally, whenever we are using the name truss and frame, generally student says, yes sir, it is used to support the load. It is used to bear the loads. Then the second question comes into mind. Sir, in SOM we already have studied beams. We have studied that there is a cantilever beam which is bearing some kind of load. We have already some simply supported beams which is bearing some load. So when already we are having beams for bearing the load, why we need to go for the trusses and frame? The first question arises, why? What is the need of truss and frames? So my dear, the answer to that question is, whenever you were studying this cantilever beam, this simply supported beam, or this cantilever beam which is having some point load, if you remember, you have calculated the deflection at this point. When you were calculating the deflection at this point, it was coming out to be deflection at A is PL cube upon 3EI. Do you remember that? And if you see this deflection PL cube upon 3EI, you must be aware of that this deflection is directly proportional to length ka cube, and it is directly proportional to the applied load. So my dear, if the length is very big, length requirement is very big, like railway bridges are very big, you know, they have to pass through the rivers. They are not like your homes. They are having very big requirement, big length is there. Like stadiums, you know that stadiums are also very big. Airports, for such applications where beams cannot be used because of the length, because otherwise deflection is going to be quite bigger. If loads are very high, so for these two conditions we cannot use the beams. So for such conditions we are coming with some other application, some other kind of members. Those are said to be trusses, in which we are joining the members end to end like this, and these are the number of members which we are joining, and they will be able to bear more and more loads with lesser deflection. You may be thinking, sir, what will happen if more deflection is there? If you remember, whenever we are going for the designing part, you must have seen in the SOM that you are writing that stress is P by A, and you were writing that should be equals to less than equals to sigma permissible. So you are designing the member for the stresses. At the same time, my dear, you calculate the delta, which is PL upon AE. So when we are going for design, this criteria of design is said to be strength criteria, where we are considering the stresses. There is another criteria which is said to be the rigidity criteria, my dear. So in the rigidity criteria, what we are going to do is, we are going to say delta should be less than equals to delta permissible. So my dear, if delta is going to be bigger, if deflection is going to be bigger, then my dear, the chances of failure of component with rigidity criteria would be more. And in real application, we need to design for both the criterias. We cannot accept any amount of deformations, because generally when we are talking about beams, they are also having concrete, which is brittle material, cannot bear much tension. So that is the problem. We cannot bear any amount of bending, any amount of deflection. That is not feasible. So that is the problem. We need to work over this, and that is the reason why we come up with the trusses and frames, my dear. But when we are talking about trusses and frame, they are not same thing, they are different. So first of all, I will be showing you some applications of the trusses. This is the application of railway bridge. You can see how large it is. Here beam cannot work, and you can see how these triangular members are joined like this. You can feel it. So this is the example of truss and frame. First example. Second example, this is the case of stadium, roof of the stadium. Okay, roof of the stadium. You can see this. Other application is, this is a scene of an airport, the roof of an airport. That is also very big structure it is. Yes, very good, Shashi Kiran. Very good. Okay. Okay, AU student, I can understand your problem. Okay, but I cannot help in that. Try to get maximum by reducing the quality if you can. So guys, this is one more example. Okay, this is for some kind of service center. Okay, and you can see here also they are using the trusses to bear the load. I feel you can feel these applications. So all these are the applications. This is the case when they have very long roof. So for such cases, they are never using the beams. We are using the trusses or frames there. Okay, we will see what is the difference between truss and frame also. But before that, let us see the types of trusses. One truss is said to be plane truss. Second truss is said to be space truss. Plane truss is nothing but the two-dimensional truss. Space truss is nothing but the three-dimensional truss. So when, my dear, all the members are in the same plane, we will be calling this truss to be a 2D truss. And if all the members are not in one plane, then we will be calling such truss as 3D truss. or space truss. I will show you some of the example which we have just seen. This is the example of 2D truss. Okay, why? You can see they are in the same plane. Okay, so it is a 2D truss. If you see this, this is a 3D truss. Okay, then you can see this is once again a 3D truss. Then you can see this is a 2D truss. Okay, members are in the same plane. And then, my dear, we can see some other examples. If you see this here also, you can have an idea that it is going to be a 3D truss. Okay, so that is how we can have the feelings. Now, my dear, as you know, we are going to have some analysis of trusses. And for analysis of trusses, whenever we do analysis, we take some assumption. Like when you derived sigma is equals to P upon A in the SOM, you have taken some assumptions. So for analysis of trusses also we have some assumption. First of all, you may be thinking, sir, what we are going to do actually in analysis? In analysis, our target is to find out the force in each member. Why we want to find out force in each member? Because once you are going to find out the force in each member, we can find out the stress in each member. Once we get the stresses in each member, we can go for the design, because for design purpose, we need the value of stresses. This is something what we are looking for. I feel you are getting it. So what are the assumptions under which we are going to work with? The first assumption is all the members are connected only at ends. Like if I'm going to make a truss like this, if I'm going to make a truss like this, you can see all the members are joined at the ends only. And if let us say we are having one member like this, then this blue member will be either joined at this and this point. Here there is no joint. Here there is no joint. Means if we have a member, this member will be joined at this and this point, at no other point. You may be thinking, sir, if by chance we are going to make joint here, then what is the problem? Then it would be called as frame. So this is the first difference point between truss and frame. I feel you are getting it, guys. Yes, this is the first problem by which we can separate or differentiate truss and frame. Second point is all joints are frictionless pin joint. We are assuming that these joints are pin joint. Whenever I say this type of things, many students feel, sir, it is really assumption. Have you ever seen the pin joint? Dear, I am not talking about the pin you are using here to just join to you can say parts or not. Whenever you have some kind of pins, I am not talking about that pin actually. But pin joints exist in reality. I will show you some application also. Sir, weightage kitni hai EM ka? Aman, I would like to say that for engineering mechanics, weightage can vary from 4 to 8 marks if you see the previous year's papers. But from recent years, if you see, mechanics weightage have been increased because syllabus also become double. And third thing I would like to add, from truss every year one question is coming. Okay. Definitely AU student, it will be there. If you are really having the issue, you can watch recording. Otherwise, you can try from your parents. They may give you the internet for that. Okay. So my dear, yes, these kind of joints are really existing. Like if you see this application, this is pin joint only. So pin joint is not a theoretical joint. You can see like this is roller support. So as I said, pin joints are reality. It is not like I am saying that pin joint is not an assumption only. It is also present in reality also. Okay. Then we are talking about loads are only applied at the joint. Here we have made the assumptions that every member is joined at the joints only. And also there is assumption loads are acting on the joints only. Means I will be having load either at this point or at this point or at this point. So load cannot be present in the member other than the joint. This is my assumption. Because if I am going to take force here, then my dear, it would be called as frame. Because in the trusses, we are assuming that members would be either in tension or in compression, only axial loading. So definitely bending should not be there, shear should not be there. If this force will be coming, then this member would be coming in shear force, because of which it can bend also. Then it would be under combined loading, which is not our assumption. So as per the assumption, yes, in frames we will be assuming that both can be there, but in trusses loads are acting on the joints only. This is our assumption. All members are subjected to only axial loading, as I said. That is why they are two force member. They will be either in tension or in compression. If those members are in tension, they are called as tie members. If they are in compression, we will be calling them as strut. I feel everybody knows that. If a member is in tension, it is said to be tie. If it is in compression, it is said to be no issue, AU student, no issue. If you are facing difficulty, you can watch recordings. Okay, go as per your convenience. Okay, no need to go for such spending, because I feel after 12 your data will be renewed. You can watch after that also. Okay, so don't worry. So guys, next is the weight of the members are assumed to be negligible. You know, in all so many engineering mechanics type of topic, we are assuming the self weights are negligible. We are not working with the body forces in general. So all these are the assumptions with which we are moving ahead for the analysis of trusses. Okay. So if you are preparing for GATE, you can download the ebook from the description of this session. I would like to tell you one more thing. You must have seen every time when I have shown you trusses, I am using generally two supports. One is hinge support and other is roller support. Okay. So my dear, I feel this also in strength of material, you know that what is the benefit of this kind of supports. If we are using two roller support, then the problem with the roller support is they can only bear the vertical loads. If some load is coming into the inclined direction like this, then its horizontal component cannot be bared by these two. Then you will see the motion of this beam, which we never want. So that is the reason whenever we are going for the beams or trusses or any member, we need to have a support which can bear the horizontal loads also. So my dear, that is why whenever we are using two roller support, it is said to be unstable condition, because it cannot bear the horizontal loads. On the other hand, if you are going to have two hinge support, then many students feels this is not a good connection, because here there are 4 reactions coming and they feel with 3 equilibrium equation we cannot solve 4, that is why it is bad. No, if we are facing difficulty in calculation, we cannot say that question to be bad. We cannot say that application to be bad. So guys, this is said to be indeterminate. But why we are not preferring this? It is not because we are facing difficulty in solving this. When we are talking about practical application, we don't think that it should be easy to solve. No. The reason behind not using this condition is if temperature varies, there would be some thermal strains. And my dear, both are rigid support. Then because of thermal strain, the beam or the truss or the member will bend like that. And unnecessarily bending stresses will be coming without any load. So to avoid such situation, we are considering one hinge and one roller, because this hinge support can bear the horizontal reaction and this roller support will allow some thermal elongation, and because of that both the issues are resolved, and that is why we are always using one hinge and one roller. Generally people are thinking that roller support is assumption. It is not there in reality. I would like to show you that roller supports are present in real practical application. You can see that roller support is there. You can see that roller support is there. So guys, roller supports are yes present in the real application. It is not an assumption only, they are always present. So in trusses, we would be considering in general this combination where we would be having one hinge and other roller supports. Because of that, total number of reactions would be 3, 1, 2 and 3. So total number of reactions we will see as equals to 3. So guys, do like and share the session so that we can move further. I feel you are enjoying it. This is how we are going to talk about. I will be taking everything from basic and everything would be covered. If you don't know anything about truss, then also you will be master in truss after this session. Okay. So moving further guys. Now we are going to talk about, there are 3 types of members in a truss or frame. We are not talking about frames in our syllabus, only and strictly trusses are there. Then I would like to say there are 3 types of member. One type of members which are said to be in tension, we call such members as tie bars. There are some members which are found to be under compression. These are said to be strut bars. Okay. And there are some members which do not have any kind of force. They are said to be zero force member. Now you may be thinking, sir, when any member cannot bear the load or is not bearing the load, why that member is present in a truss? Then I would like to say, my dear, there are 2 things. One thing, it is for the upcoming loads. Maybe in the future some extra loads will come which we are not aware of. For those kind of load, we are providing these types of member which are said to be zero force members. Thanks, AU student. And second thing, my dear, there is one more thing also for that. It is not only one thing. The second thing is, my dear, whenever we are going to make a member, sometime we need to make it in such a way that it must be incollapsible, yeah, non-collapsible. You will not be understanding right now the meaning of non-collapsible. I will be telling you that in the later stages of this chapter. So at that time you will get to know what do you mean by non-collapsible or incollapsible. To make the rigidity of the members, sometime we require some members which may not bear any load but can surely provide us the rigidity condition which is required for the trusses. So for that we will go on separately at the end of the truss topic. For the timing, tie, strut you get to know. Now the point is, when we will get to know that member is in tension or compression, how we will identify such members. So I would like to say we will go with the concept of spring. If you see this spring, you know that if we are going to have the forces on the spring like this, then you will call the spring is in tension. But these are the external forces. Internally, what would be the feeling? If someone is trying to extend my hand like this, what I will resist like? I will resist like this. Means internal forces which will be generated for such case would be away from the joints. They would be away from the joints like this. So if you have forces like this, internal forces are away from the joint, it means member is in the tension. Similarly, my dear, if member is under compression, like this, then what the member will try to do? Member will try to do this. Member will try to resist like this. Then internal forces will be coming towards the joint. Internal forces will be coming towards the joint. So if internal forces are towards the joint, it means member is in compression. Always feel it like that. If member is in compression, it will try to apply force like this towards the joint, and if it is in tension, it will try to apply the internal forces will be away from the joint. So this is the identification. It is very important slide. You may be thinking why sir is discussing this, because in majority of the trusses question you are capable of calculating the values. The problem comes to identify whether this member is in tension or compression, because there are two options which have same magnitude, one with tension, one with compression, and their students are getting stuck. So for that issue I have given you this way, and you can very easily identify this and move further. Is it clear, guys, for everyone? Then I will like to say in frame members, okay, that we have already discussed. With the trusses frame we have already seen. Shashi Kiran, sir, can we remember as incoming? Shashi Kiran, that is on to you, how you want to remember, but I told you how we are going to decide. In the frame we are having that kind of things. In the frames, loading can be at any point. In the frames, a complete member can be joined at multiple places, not at ends only. Loading can be at any point. Here they are not joined with the pin support, but they are having some strong rigid connections like welded joints. So these are the differences, but frames are not in our syllabus. We are going to discuss here only the trusses. So that is why we need not to worry about this. Then, my dear, we are moving into this wonderful things. Sometime questions may be coming that please identify whether this frame is a perfect frame, or this frame is a deficient frame, or this frame is a redundant frame. So I would like to tell you, to decide this, we have two conditions. Then a perfect frame is defined as, number one, statically determinate. First thing. Second thing, it is capable of bearing loads. Without collapsing. So my dear, if these two conditions are getting satisfied, then we will be saying a frame to be a perfect frame. Actually, I have used this word statically determinate because actually there is an equation which I will be deriving using this concept. So if that equation is satisfied, we can call that truss to be a yes, we can call it as a perfect truss or frame. So my dear, that equation is generally given as m plus 3 is equals to 2j. Everybody know this equation? I would be telling you how this equation is coming, because this equation is written in this point. Why I have replaced this with statically determinate? To tell you that this equation is coming from statical determinacy. When we call a condition to be statical determinate, yes, welcome back Teju, English padha hai. Yes. So guys, what do you understand by statically determinate? If number of equilibrium equations is equals to the number of unknowns. If that condition is satisfied, we call it as statically determinate. So my dear, if we have in a truss total m number of members, then we need to find out the forces in those members. So if m is the number of members, then my dear, we need to find out the forces in these members. So this is the number of unknowns. Plus you have one hinge support in which two reactions are coming. You have one roller support in which one reaction is coming. So total number of unknowns are m plus 3. Then my dear, whenever we are talking about any joint, because forces are acting only on the joints. So if we are talking about any joint, whatever be the number of forces acting on this joint, they are coplanar and concurrent. Coplanar plus concurrent. In equilibrium, you must have seen, if we have coplanar concurrent force system, for that particular type of system, there are two equilibrium equations, summation fx0 and summation fy0. For one joint, we have two equations. If the number of joints are j, then for one joint, two equation. For j joints, how many equations? 2j equations. So we will be saying the number of equilibrium equation is 2j, and if you will equate them, it is the condition of statically determinacy. And if that condition is satisfied, after that, if the truss is capable of bearing load without any collapsibility, we will be calling that frame to be a perfect frame. The point is, we can definitely check the first thing. How we will check the second thing? So I am telling you the shortcut today. If you see any truss, it is made up of only triangles, then second condition is automatically satisfied. I will show you the examples with that. First of all, you see this. The number of members are 3. The number of joints are also 3. 1, 2 and 3. So you can see, first of all, equation is satisfied or not. M plus 3 is equals to 2j. Is it or not? M plus 3 is 6. 2j is 6. That is equal. First condition satisfied. Truss is made up of triangular members. Second condition also satisfied. It is a perfect truss or perfect frame. Is it clear or not? If we see this member, here the number of members are 4. The number of joints are also 4. 1, 2, 3, 4. And 1, 2, 3, 4. So 2 into j is 8. And m plus 3 is 7. So you can write m plus 3 is less than 2j. M plus 3 is less than 2j. 8, 7. In this condition, we will call it deficient frame. No need to check the second condition, because when first condition do not satisfy, it is simply not a perfect frame. We will be calling it as a deficient frame. Now, my dear, we will be checking the next case. You already know members are joined only at the joint. So here the number of members are 1, 2, 3, 4, 5, 6. Number of members are 6. So we can say m plus 3 is 9. Joints 1, 2, 3, 4. 2j is 8. This time m plus 3 is more than 2j, and that is the condition said to be redundant frame. Once again, the first condition do not satisfy, we will not check for the second one. So guys, what do you mean by redundant frame? Redundant means there is some member extra. Even if you take one member out, then also it can bear the loads. This member is extra. That is the meaning of redundant. Redundant means which can be reduced. And what is deficient? Deficient means it requires some member. So it requires some member. If that member would be coming, then it may become a perfect frame. May, I am saying, because second condition must be satisfying. So guys, I feel everybody got it. Shall we move on now? Shall we move on now for some more examples? There is one more example I will be taking. Let us say we are having this. Let us say we are having this. This is triangle and this is the case. Just feel it. If you are having this case, just feel it. If you see the number of joints, 1, 2, 3, 4 and 5. Here number of joints are 5. Okay, first case. And number of joints are 5, number of members 1, 2, 3, 4, 5, 6. The number of members are 6. So if you see m plus 3 is 9. 2j is 10. So m plus 3 is lesser, it is deficient. It is deficient. Deficient means cannot bear the loads. It is deficient. I feel everybody is getting. I didn't get what you are asking, gap, Teju. So just try to put your question in some more perfect manner so that I can help you. And second condition, let us say we have one member like this. If we add this blue member, now the number of members will become 7. Joints remain the same. So number of members are now 7. So what is m plus 3? M plus 3 is 10. What is 2j? 2j is 10. So this time you can say 2j is equals to m plus 3. First equation is satisfied. First equation is satisfied. But my dear, first equation is satisfied. Second condition says collapsible should not be there. In theory of machines and in other subject you have seen that if we are having a 4-bar chain like this, if you will try to apply force here, it is going to rotate like that. So that should not be there in the case of trusses. So that is why if it is made up of all the triangles, here it is 1 triangle, 2 triangle, 3 triangles, all are triangles. Second condition is also satisfied. You would be saying that it is a perfect truss. Okay, it is a perfect truss. Now I will show you one more example where I will show you one more example that will giving you more idea for that. Let us say we are having a truss like this. We are having a truss like this. Like this. Like this. Okay. Here I am putting one here, one here. All the members are triangles only. So if you see in this, if I say this is member number 1, member number 2, member number 3, 4, 5, 6, 7, 8 and 9. So the member are 9. So m plus 3 will be 12. The number of joint 1, 2, 3, 4, 5, 6. 2j is 12. This is the perfect frame. So you will say 2j is equals to m plus 3. First condition satisfied. All are triangles. So both conditions are satisfied. It is a perfect truss. But if the same number of members are joined like this, if the same number of members are joined like this, just feel it like this. Just feel it. If the same number of members are there, you can see number of members 1, 2, 3, 4, 5. Okay. Then it is 6, 7, 8, 9. So number of members are 9. So m plus 3 will be 12. 2j is 12. So my dear, first condition is satisfied. But if you see in this case, this part is not a triangle. So if any load will be coming on this joint, under this joint, you will see the movement of this part. And because of that, it is not a perfect truss. It is not a perfect truss. So I feel now you get the idea of perfect truss. Guys, don't take it anyway. This type of question you can expect because now they are coming into the new areas from where questions have not been asked before. They are entering into that. So you need to be ready for that. Okay. So m is less than 2j minus 3, then there will be gap. Okay. Trusna, define which type of Trusna. Dear, that's what I said. If you are going to have, I feel you want to know about superstructure kind of thing. So here that is not required. Okay, here you can simply say that it is a deficient truss or frame. That is enough for that. Okay. Now, my dear, this is an example I have shown you. So you can see here, this is the case how the trusses are given. You can see this is triangle, this is triangle, this is triangle. So my dear, here what we need to do actually in the analysis, first of all we need to know the support reactions, and after getting the support reaction we need to see the forces in the number of members. For that there are two methods given. First method given for that is method of joint. First method given for that is method of joint, and second method given for that is method of section. First is the method of joint, second is the method of section. So guys, in general, majority of the question you will be able to solve just with the method of joint. But for some of the questions, method of section can give you quick answer. Otherwise, only one method can be used for any type of questions. But if you know both, you can save your time in the exam. So let us start one by one. I'll be starting with method of joint. And guys, here theory is nothing in this topic. In this topic, everything is numerical only. So that is why I will be performing a numerical with method of joint and then by method of section. And then we will see the zero force member, and that would be the completion of the trusses. So we will go in very simple manner. So first of all, this is a question for which we are going to start with. You can see there are two forces, 2000, 4000. And you know there are two supports at A and C. You know there would be a support reaction RA. And because it is hinge support, there should be a HA, horizontal reaction, and there should be one support reaction RC. So guys, when you are going to find out the support reaction and the forces in the members, I will be telling you the procedure along with the solution. So first of all, if this is given to us, our first task is to find out the support reaction. So first of all, we will be finding out the support reactions. And I feel everybody have done the strength of material part. How we find out the support reaction? By going with the equilibrium equation. You will say first summation Fx to be 0. You will see there is no force in the x direction except HA. So just by doing that, you will say HA is going to be 0. Now my dear, we need to find out the support reaction at A and C vertical ones. We will be going for summation F vertical is 0. Teju, I feel you have done some mistake. You can see this is 2000 downward, 2000 and 4000 downward, RA and RC upward. So we can write RA plus RC is equals to 6000. This is the case. Now my dear, I would be applying the summation moment 0. I feel Shashi, you have given the wrong answer. Try it again. So when we will be finding out with summation moment to be 0, you can take moment about any point, either this hinge or this roller. I am taking about this A point. You can see that if the total is 3, this is equilateral triangle. You can feel it. So if this is equilateral triangle, all sides are equal. So obviously this will be 1.5 by symmetry. This will be 1.5 by symmetry. So the things are very easy for you here. 1.5 by symmetry things are coming. So you can write first of all 2000 into 1.5 clockwise. 2000 into 1.5 clockwise means positive. And you know RA is passing from here. I will not be taking the effect. Then you know 4000. 4000 is at 4.5. 4000 is at 4.5. 4.5. Then you know this RC is acting in the opposite direction. Minus RC into 6 is equals to 0. Now you can find out. Okay, Shashi, Teju, anybody else who have tried this, you will be getting the RC from here. Can you tell me what is the value you are getting? You can see that, na? This is passing from here only. This is creating cloak. This is creating cloak. This is creating anti-cloak. So you will be getting the value of RC from here. So you can see this is 2000 into 1.5, 4000 into 4.5. And after solving what I am getting for you guys, I have done this question and I feel we will be getting RC to be 3500 Newton and RA to be 2500 Newton. Very good, guys. So these are the values we are going to get. Shashi Kiran, I feel you have done some mistake in calculation. These are the values of RA and RC we are going to get. 3500 and 2500 would be the support reactions that we have done very easily, and that is going to be the first step because otherwise we cannot move with. I will tell you why we cannot move with. So my dear, when we are moving to the second thing, now we want forces in the members. For that we have two methods, method of joint, method of section. Method of joint says that if entire body is in equilibrium, then every joint will also be in equilibrium. And if you are going to have one joint, on that joint, whatever the forces are acting, whatever be the forces acting, they all are coplanar and concurrent. For such a system, we have only two equilibrium equations. Summation fx0, summation fy0. Two equation can give you two unknowns. So my dear, you can start with any joint which is having two unknowns. So that is why if you are finding out support reaction, that will help you, because all the times you will see two unknowns are present. Like if you see this case, if you are going to take this joint, you can see this member we don't know the force, this member we don't know the force, this member we don't know the force. We have three unknown, so we cannot start with this joint. But if you see joint A, this member is having one force, this member is having second force, and this support reaction is the third force. So if out of these three RA is known to us, we can go with joint A. So that is how support reaction is going to help us. Yes, if in some particular condition you have any joint with two unknowns only, then without going for the calculation of support reaction, also you can start with. For this case, what I can find is joint A is a joint where only two members are there, because this reaction is known to us. So how and what we are going to do? If you are going to take the method of joint, this is the procedure how I am going to solve it. I will be considering the joint A here. And if you are going to take the joint A, you know there is a support reaction. The value for that is already found out by us. That is nothing but I feel 2500 Newtons. This is the value. And my dear, this value is known to us, but now about the forces. One member is this, other member is this, and the angle between them is 60 degree. Now my dear, we need to assume the forces in the member. We need to take some directions for that. Now there are two ways. One is arbitrarily take any direction. If your answer comes positive, assume direction is correct. If answer comes negative, assume direction is wrong. Second way is use your common sense. That will help you in 90 to 95% of the cases, and you will get right direction. How I am telling you. So common sense, we must understand what it is. If this force is acting upward, then my dear, it is damn sure that to balance this, some downward force is required. Downward force can be given by this member only. So we would be having one force in this member. Okay, and this force would be written as F. This joint is A, so towards A from D, FAD is the force. And similarly, if this force is in this direction, its horizontal component needs to be balanced. That would be balanced by this component, and that is going to be FAB. Is it clear or not? So when we have assumed the direction, now what is the case? If we are going to have the directions now we will be finding out these two values, and if answer comes positive, it means assumption is correct. If answer comes negative, it means assumption is wrong. I feel Shashi Kiran have given the values. Please guys solve it. If I would be using the summation fx0 and summation fy0, we can write 2500 is equals to FAD sine 60. Then we can write FAB is equals to FAD cos 60. With this we can find out the value of FAD and FAB. Okay, I'm waiting for the answers. Shashi Kiran have also given the answer. Teju have also given the answer. What about others? What about others? And yes, we would be getting the value. You would be getting the value FAB and FAD. AD is 2887. 2887 Newton. AB is 1443 Newtons. Very good. Both values are coming out to be positive. Very good, Shashi. I understood that. So both these values are coming out to be positive. It means assumed direction is correct. So if you see the assumed direction, here the assumed direction is towards the joint. Towards the joint when the member is under compression. So my dear, it means AD member is under compression. Here if you see, it is away from the joint. It is away from the joint. It means member is under tension. So this force is tensile. Am I correct or not? Please tell me. Everybody understood? Because if you understood this, we need to repeat it again and again. So now what we have done is for joint A. Now you got the values of forces in this member and this member, in this member and this member. Now we can go for joint C also, because at joint C also we know RC and we can find out the forces in these two members. Okay, so let us see the joint C now. When we see the joint C, at joint C, we are going to have, don't worry, I will not waste your time, only one more calculation and we will move further, because we just need to learn the concept. This marathon is to understand the thing and to have some practice so that you get to know how you need to attempt in the paper. Okay, great. So let us move further, guys. So this is RC value. You know RC is 3500 Newton. Then my dear, we have BC member and CE member. BC member and CE member, the angle is 60 degree. Shall we go for the common sense? Yes. For this upward, here should be downward, and for this it should be like this, because this component is going to the right, so we need left hand component. And how you will write this joint C? This is force FCE and this is force FCB. So you got these two values. Now once again, what we are going to do, my dear, what we need to do here, once again summation Fy0. You will be having FCE into sine 60 is equals to RC. Then FCE cos 60 is equals to FCB. From here you will be getting the value of FCB and FCE. This is how we are going to use the joints. Yes. So guys, on 27, 28, 29th, we have also planned for you the marathons of aptitude and English. So the students of or viewers of this channel are again going to get this. As I said, for you guys already planned aptitude English. Okay, everything. So Vinay is saying 4.04 and 2.02. So the answer for FCE will be coming out to be 4041 Newton. So I feel answer is correct. For FCB, we are going to have 20.5 Newtons. So guys, assumed directions are correct. That's why answer is coming out to be positive. So my dear, we get to know that if you see this member, if the force is acting away from joint means member is under tension. So my dear, CB is under tension. Here it is towards the joint. Towards the joint means compression. Everybody understood? Now if we want to take the joint E also, this force is known to us. There are only two unknowns. So one last joint we are taking, then we will move to the method of section. Okay, so now we will see the joint E, the last for us, joint E. If you see joint E, here the force is 4000 Newton, and we have also find out this force is towards the joint. This is FEC now, and we are going to have one more force here, one more force here. Now you need to take arbitrary direction. Common sense may not work, because if this component is giving in this direction, you are assuming in this way, and here we are assuming in this way. This is FED and this is FEB. So guys, you can see the angle. You can see the angle. This angle is 60. This is 30. By symmetry, this is also 30, because it is equilateral triangle. So yes guys, wonderful. So just find out the values. You can use the equation. How? You can write 4000 downward, then minus FEB cos 30, then plus FEC cos 30 is equals to 0. Second equation is FED minus FEB sin 30 plus, sorry, minus FEC sin 30 is equals to 0. This will give you the unknowns FEC and unknown FEB. After that, we will move to the method of section. These are the last two we are finding out. I feel Shashi have given the answer. 581 is fine. 581 for FEB. FEB is 581 Newton. If you see the direction for FEB, it would be coming under compression. So if you are talking about FEB, the forces we have assumed in this direction. We have assumed away from the joint. We have assumed the member to be in tension. But when you will calculate, the value will be coming out to be negative. So when the value is coming out to be negative, it means assumed direction is wrong. So real direction for EB will be this. So this means towards the joint. Towards the joint means compression. So you can write it as 581 compression. This is the real answer. Either minus 581 with the assumed direction or 581 in compression. This compression is not coming because of this negative. This negative is saying assumed direction is wrong. Here negative will not tell compression, positive will not tell tension, because these are the forces we are calculating. Okay. So similarly, when you will find out FEC, you will be getting FEC to be 4041 Newton. 4041 Newton. Very good guys. So FEC 4041 Newton, that also compression. And that I feel already we have calculated. So we were requiring FEB only. FED is required. What is FED? You will get FED to be 1732. FEB to be 577. FEB to be 577 Newton. And FEB is also coming out to be compressive. I feel the same only. I have written it twice. Everybody got it? Everybody got it? Please tell me that. Everybody got it? Polo bhai. The second unknown is, I feel, FDE. If you will find out FDE, then FDE will be coming out to be 1732 Newton compressive. So after solving, you are getting this answer. I have given you all the values guys, and this is something called as method of joint. Please tell me everybody understood this or not, then we are moving further. This was the wonderful method of joint. Shashi very good, Vinay very good, Teju very good, bahut hi badhiya. Moving further guys, this is the method of joint. Okay, so now my dear, we will see the method of section. But before that, okay, now we will see the method of section. But before that, let us talk about the zero force members. One more topic is there from which the questions are coming. Identify the zero force members. There are some members in which neither tensile nor compressive force is acting. They are said to be zero force member. So my dear, when they are zero force member, we can identify them and remove them before going for the analysis. Because maybe out of 10 members, 3 are zero force member, then we need to go for calculation only for 6 to 7. This will reduce our task of calculation. and I told you they are there if some additional load comes for that purpose. So we need to find out now zero force members. What are the zero force members? So my dear, if you want to find out zero force members, there are some shortcuts for that. So my dear, I will directly be telling you the shortcuts. If you have two non-collinear members like this. If there are two non-collinear members, this is member number 1, this is member number 2. And at this joint, there is no force. Force value is 0. If you have a joint at which two members are connected which are non-collinear and there is no force onto that joint, then my dear, both these members are going to be zero force members. Both these members are said to be zero force members. This is the first condition. What is the second condition? If we have three members, 1, 2 and 3. 1, 2 and 3. Out of these three members, these two are collinear. These two are collinear. And at this joint, there is no force. Then this is said to be the zero force member. These are the identification. Even otherwise, you need to apply the equation summation fx0, fy0. Why to do that? These are the shortcuts. We can use it. So guys, then this is going to be the zero force member. So if there are three members at a joint, two are collinear, then third member will be a zero force member provided there is no force at the joint. Very good, Teju. Wonderful, guys. Moving to the third point. If there are two non-collinear members at a joint, okay, like this. Two non-collinear members. Here force is acting in a direction like this. Okay, so this force is acting in the direction of this one member. So my dear, in the one member, force will be simply F and this will become the zero force member. This is the third condition. So guys, these are those three conditions which if you find, you can directly identify zero force member and you can simply straight away remove them. You can simply straight away remove them. Okay, because they need not to be analyzed. You can directly take them away. So this is how we can go for zero force members. And my dear, now we will be moving for the method of section. Now we will be moving for the method of section. Now we will be moving for the method of section. So we are considering the same question for method of section so that we need not to go for multiple analysis, because I need to save your time also, because after me Sonu sir will once again join. Okay, so to go for method of section, I am taking the same question. So here, first of all, when I will go for method of section, let us say the force is asked in three members. Let us say I need to ask you the force in member DE, in member DB and in member AB. I am asking you the force in member DE, DB and DA. Now if you are going for method of joint, first of all you will be going for A, then you will be going with the other joint C, then you will be going for E, and then you will be going for D, and in that way you will be finding out force in all the members. Thanks, Shashi Kiran. Thanks for your wonderful words. Once again, thanks. And if you have not joined my Telegram channel, you can join it. There you will get some handwritten notes also. Okay, previous year's question also. If you need any other kind of data, you can get that. Okay, guys. So now we are moving further. So if you want to find out the forces in these three members, 1, 2, and 3. In method of joint, it is going to be a very lengthy procedure. You need to attempt 4 joints, which we have done. So when you will be doing that, it will take a lot of time. Here, method of section can help you. So my dear, first thing, when you are using the method of section, it is using the equilibrium of one part, one section of the body. Like method of joint uses the equilibrium of joint, method of section uses the equilibrium of a section. But my dear, once again, the condition is same. If you will be dividing this truss into two parts, then my dear, it is going to be a planar body. There would be some forces which are co-planar but non-concurrent, because it is not a joint, it is a section. So for that there are three equilibrium equations, that is summation fx0, summation fy0 and summation moment 0. And with these three equations you can find out only three unknowns. So you can find out the forces in those three members which can be cut by a single line. Like if I cut with this line covers all the three members 1, 2 and 3. If this line is consisting of any fourth member, you cannot use method of section, because only three unknowns can be found out. So you would be taking a line which is passing from those three members. There should not be any fourth member which is coming in the way of that. Is it clear or not? Like if the forces are asked between this member and this member, then if you will be taking the line will be passing from the four members. You cannot use it. You need to take some other section or method of joint. So section should be considered in such a way that three members should be covered by that section. So my dear, here also first step would be to find out the support reaction, which we have already done it. So we will save our time here, because we already know RA is 2500 newtons and RC is 3500 newtons. That we already know. So no need to worry about that. So I am going to take this into two parts. This is the section which I am going to make to find out the forces in these three members. You can see the section is passing from all the three members. So when I will be dividing it, my dear, now the internal forces will become external, because this is divided into two parts. We would be having one force FDE, I am taking it as F1. I will be having one more force FDB, which is I am taking F2. And third force is FAB, that is F3. These three we need to find out. Now my dear, you can take this section separately. And for this section, now you have only three unknowns, because reaction is known to us, this force is known to us. You just need to apply three equations, summation fx0, summation fy0 and summation moment 0, that will give you the unknown. Yes, Teju, are you getting it or not? Vinay, are you getting it or not? Shashi, are you getting it or not? So I am doing it for you also. So we have three unknowns, my dear. The first unknown is this force F1, the second unknown is F2 and third unknown is F3. So in this figure you can see, you can feel it again. So my dear, if you see here, what are the vertical forces? We have this RA and this 2 kilonewton, both are known to us, we need not to go for it. But this F2 will be having a vertical component. This F2 is having one horizontal component, one vertical component. So my dear, you can go with the equations. First equation says summation fx to be 0. You need to see the horizontal forces. This F3 is the horizontal force. You can write F3 plus. Then you have F1 also horizontal, plus F1. You know this angle is 60. This angle is also 60. So you can write plus F2 cos 60 is equals to 0. This is equation number 1. One equation, three unknown, we cannot go for it. Shruth, I'll repeat it. Okay, first let me write the equation, then I'll repeat it. Then my dear, second equation is summation Fy to be 0. If you see summation Fy, you know that this is acting upward. You will write plus Ra, which is known to us, 2500. Then minus 2000 downward. Then you have this F2 sine 60. F2 sine 60 is equals to 0. This equation will straight away give you F2. So we get to know one unknown. And if you put this F2 value here, still we have two unknowns. So we cannot solve it until we use the third equation, that is summation moment 0. And here I would like to add a point. Whenever we are talking about summation moment 0, generally students are getting confused, sir, about which point. They feel I can take moment about a point only in this section. No, you can consider the point in the other section also. Like I know that if I would be considering this point, means I would be taking the summation moment of 0 of these forces about this point B, then I know that this force is passing through this force is passing through this. I would be directly getting this F1. So if I would be taking summation moment about B to be 0, this force is passing from it, this force is passing from it, I can directly find out this value. How I can do that? Summation moment of B to be 0. You know that this RA is creating clockwise. So I will write RA into 3. RA is known to us. Then this 2 is acting like this, anti-clockwise, minus 2000 into 1.5. You know that by symmetry. Then this force passing from B, this force passing from B. We have this. I will write F1. And what is this distance? What is this distance? If this is 3, this angle is 30. This is 3 cos 30. So I will write, my dear, that is going to be plus or minus clockwise, plus F1 into 3 cos 30 is equals to 0. So guys, when I am writing this, you would be getting the value of F1 from here. You already know the value of F2, and then you can find out the value of F3. This is the wonderful method of section. Please tell me guys, you got it or not? Shashi, Teju, Shruth. Sir, when we consider point on another section, we have to consider left section forces only. Dear, when we are going to talk about left section equilibrium, then equilibrium of left section means forces of left section only will be considered. But that equilibrium can be about any point. And when we are going to consider on the second side, when two forces are passing from that, when moment becomes easier for us. You can also take moment about A also, but that would be difficult because many forces, only one force is passing from that, only one unknown. You need to solve once again the two equations. So you can take the forces of left side about any point at right hand side or at any point wherever you want to take. Shruth is asking, sir, how to consider the section. While considering the section, we need to take care of two things. First thing, section must pass through all the three members. Second thing, no fourth member should be there because you can find out maximum of 3 unknowns. So if in the same question, they are asking us, like for this question I am saying, if they are asking the force, let us say this member and this member, then this section you can take. You can take this section. Okay. But if they are asking the force in this member, okay, and this member, then if you are going to take the section, it is not passing through 3 members. It is passing through 4 members. So this section is rejected. Section should be such that it must pass only from those 3 members in which you need to find out the forces. Ha, Vinay, it is your choice. How omega mean consider? Dear, you can consider in this way, like I am telling you. Like this force, you will be rotating this about the point. It is clockwise. Like this force, you will rotate it about the point, anti-clockwise. Like this force, you will rotate about the point, clockwise. So you just need to rotate the force vector about that point. In case of method of joint, only 2 unknowns should be there, and in case of method of section, only 3 unknowns are there. Akib, method of joint, 2 unknowns should be there from one joint. If you have many joints, from one joint you can find out 2 unknowns. Okay. For more than one joint, you can find out many. Okay. That is the point. Very good. But your understanding is very good. So guys, please tell me everybody understood this topic, because questions are going to be there. And dear, this is a topic which I could teach you for 4 hours also. But this is going to be wastage of time in that case. That is why I have taken in such a way that I covered everything. Zero force members covered. Method of joint covered. Method of section covered. And perfect truss covered. Truss versus frame covered. Difference between truss and frame covered. Everything is covered in just 1 to 1.5 hours. Not even that I have taken. Great guys, great. So I feel after me Sonu sir would be about to come. So we are waiting for a message from him so that he can join, and I will leave you for that. Okay. Sir, section should pass only through those members which were asked. No other members should be there. Dear, if they are asking in 3 members and you are having other members also, but you know the force is in that, then also it's fine. Let us say they are asking force in only 1 member. Then you can take the section which is passing through 3 members, because you can find out maximum of 3, not more than that. But in other 2, the forces should be known to us. If it is passing from that, no problem. Otherwise, you can find out 3 unknowns anyhow. Like in the question, if they ask you, I need force only in this member, like they are asking RS member only, this member. They are asking the force in 1 member. So I am helping the Shruth here. They are asking the force in RS member. So you are going for method of section, you will take the section like this. So you will find out the force in all the 3 members from method of section. Okay, there is no problem. You can take it in this way. But they are asking you 1 only. Here method of section will be easier. Otherwise you need to first of all find out the reactions that anyhow you have to do. Then you need to take this joint. Then you will be going for this joint. So 3 to 4 times you need to take the joints. So better method of section, take section here, find out support reaction, and after that you will be finding the unknowns. Is it clear? Fine, 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 fine. Sir, if 1 member, then it is easy to use. Akib Wani, like in this case, they are asking you force in RS member. If you are going with method of joint, first of all, you will be taking this joint. After taking this joint, you will be taking this joint. So 2 times you need to apply method of joints. But in method of section, you just need to take this 3 equations, your work will be over. Is it clear? Fine, fine, fine. Ha, Teju, definitely with that you can go for. Okay, definitely you can go for. Fine. Okay, so I feel Vinay, I have semester exam tomorrow. Can I know up to what time this class will be going on? Dear, that I cannot answer, because now Sonu sir would be joining. He would be answering you for that, because now his part is pending only. And I feel within 2 more hours. So sir, are you ready? Shall I leave it? Yes. Fine. So guys, don't forget, me and Abhinav sir are going to take one more session related to top 51 previous year's questions. They will be from mechanical, from civil, from XC. They would be top hand-picked questions. They will give you a wonderful revision. Be ready for this session. Okay. And I will share the link of this session, and we are also going to take one more session related to do's and don'ts. So that will help you for 3 hours of paper and the remaining 8-10 days also. So goodbye guys for this session from my side. Okay, now Sonu sir is coming. Abhishek, good evening. Okay, Shashi Kiran, great. So Sonu sir will be joining now. Okay, Akib.
So welcome back. You just write in the comment section, is my audio video fine or not? Up to what time sir class will be go on? Hardly 1.5 hour class will be there, my dear. In that portion, we need to cover friction, one important topic. After that, application of the friction. Most of the students have not covered the application of the friction. After that, my dear, kinetic of the friction, one important part. Then welcome back, Teju. Then moment of inertia and CG and work power energy. These 4-5 chapters are left. Okay. Definitely we are not going to move forward so much of thing. Let's try to cover these all the points, Ajay. So just write in the comment section. You all are the warrior. You are fight for GATE 23. Even last 3-4 hours we have invested, my dear, and your energy level, everything is at the top level. Good. So let's start the session. Let's start with the next topic, my dear, friction and the application of the friction. Sir, friction and the application of the friction in that part nearly 2 am. Yes, Surut, maybe. Friction. When the two bodies, two part, we are going to discuss in this case. In one part, we are going to cover the friction. In the second part, my dear, the application of the friction we are going to start. Yes, sir. When the two bodies tends to have the relative motion, tends to have, either they are having or not having. It is up to you, whatever you want. Abhishek, I can do one thing. If you say, sir, full night session chalo, so after each and every topic, I'll add 10 to 12 problem for you guys, if you want right now. But I am very sure that hardly few of you want like this. Otherwise, you want to cover the each and every formula, application, procedure of each and every formula with the application of one or two problem, right? Okay, sir. Sorry. What friction says, when two bodies tends to have the relative motion between each other, my dear, then friction act between the contact surface of these two bodies. What is the meaning? जब भी कभी आपके दो surface होंगे, whenever two surfaces are there, then definitely there will be a friction force. A force will be applied and they will try to have the relative motion. It does not mean they are having. If they tends to have, then there will be a friction. If they are having, then definitely friction will be there. Getting my point? Two different things. Either they try, either they tends to have, or they are having. So in this case, like see the example. In this case, my dear, the mg force or the W is applied in this direction. Normal reaction due to the contact force. In the chapter number 1, it was discussed by Abhinav Sir. If there is the contact, then normal reaction will be there, my dear. Now, if you will apply the force in this direction, then either body move, either body move, my dear, or does not move, but friction is there. Are you getting my point? You apply the force, then friction is there. If no force is applied, body is resting, at that time, my dear, friction is 0. If no force is applied and body is resting, you apply 1 Newton, friction will be there. 2 Newton, friction will be there. You will increase the applied load, friction will be there. So that will be the friction. Like this. Yeah, it will be the static friction. Absolutely right, Akif. So to study this, let's try to move further and let's try to understand all the concepts. Sir, the body, this body is a static right now. What I want to know, I just study the friction to understand each and every concept of the friction. Let's see. Is it correct that, sir, friction is not there if we can't walk? Means if you are resting, are you talking about this? If you are resting, you are not going to apply any force, then friction is not there. Do you want to say like this now? If I'm not wrong? Yeah, if the body is just resting over anything and no force is applied, then definitely friction is not there. So in the starting, I think from the next point, Shashi, everything will be clear, my dear. Just give me 1 minute. Sir, in this case, right now body is in rest condition. What is the force acting in the downward direction? Sir, W. Opposite to this, sir, N. Is it or not? After that, yes, you can say W or the N. After that, if I will apply the 1 Newton of force, my dear, 1 Newton of force only, but body is not moving, it means right now it is resisted by something. What is that one? Friction force. 1 Newton of friction force is there, my dear. Similarly, you apply the 5 Newton of force, body is again not moving. Why body is not moving? Because some resisting force is applied by the 5 Newton like this. Similarly, my dear friend, if you apply the 10 Newton of force, but body is not moving, but right now body is at the verge of motion of 10 Newton. What is the meaning of this verge of motion? Means after 10 Newton, if you apply 10.001, body will start to move. That is the limiting condition. So it means if you will apply the 11 Newton of force, my dear, like this, then in that condition, yes, in that condition, Srut, the friction force is not 11. Friction force will be the 10. So what is this? This is the limiting condition of friction. Are you getting my point? Sasi, your answer. Limiting condition of the friction. So are you not feeling in the starting no force was there, no friction was there. As you increase the force, friction was started to increase. So in this case, if I'm not wrong, are you able to feel that friction will be under the limiting condition of this, if you don't mind? Is it or not, my dear? Sasi, the answer of your question, when no force was applied, then friction in that condition was 0. Then friction will be greater than 0, equal to 0, or less than or equal to F max. If I'll draw all the conditions, between the friction and the force, my dear, then it look like that friction force is going to increase up to this condition, and after a certain condition it becomes constant in ideal condition. But in actual condition, this is the Fs max, my dear. That is the numerical value of the 10 Newton. After that, friction is not going to increase. After that, friction will be 100% constant. But in actual condition, when motion start, suddenly the limiting value of the friction decrease, and this is the right diagram that is known as Fk max, my dear. Getting my point? So what is the meaning of it? Up to this condition, up to the static condition, up to the limiting condition of the static, my dear, limiting friction, are you not feeling? If the body is not under the motion, then my dear friend, your friction force is absolutely equal to applied load. Yes or no? Is it yes or no? Agree or not, my dear? Within the friction force, like if you are somewhere here, are you not feeling friction force is also equal to applied load? So if you apply the load less than limiting value means this one, my dear, this one, then definitely your friction force will be 100% equal to applied load. But after the limiting friction, yes, very good, my dear. After the limiting friction, can I write P is greater than Fs max? Is it or not, my dear? Yes or no? Agree or not? Up to the limiting friction, friction force is 100% equal to applied load. But after the limiting condition, my dear, friction force is less than this condition. Are you not feeling in that condition? It is the problem of unbalancing. Is it or not? Can you please tell me? This is the equilibrium condition. This one is the equilibrium condition or non-equilibrium? Sir, non-equilibrium condition. And in the non-equilibrium condition, can you please tell me what concept, my dear, we can apply when resulting force is not 0? Just before the topic of truss, we have discussed the same concept. If you are able to feel before the topic of truss, as you have studied from the Dheeraj sir, with the concept when resulting force is not 0, my dear, then Newton's second law of motion is valid. Newton's second law of motion, or you can say D'Alembert principle. Both are the same thing. Excellent. Wonderful. D'Alembert principle, my dear. So let me tell you, up to the limiting friction, you will be able to apply the concept of equilibrium. And after the limiting friction, you will be able to apply the concept of Newton's second law of motion. Are you not feeling? Friction is the combination of the static plus dynamic. In the static, you are applying the concept of equilibrium, and in the dynamic, my dear, in the portion of the dynamic, you are applying the concept of Newton's second law of motion. Are you getting my point? Is it? Okay. Yes. What is that? What is that? Why this limiting friction is going to change? Sir, in ideal condition, what you write, that it must be equal to static. There is a question from Teju. After that, my dear, this is decrease up to this certain limit, and after that it will be constant. But let me tell you, even in the real situation, it is not a constant. As the applied pressure increase now, as the applied force increase, then after a certain speed, my dear, friction is again going to decrease. Sir, what is the meaning of this? Simple, Teju, that up to the static condition of the body, your friction, up to the static condition of the body, your friction will be developed in the body will be very high. When just body will start to move, due to the motion, my dear, due to that motion, your friction start to decrease, and after that, as the velocity increase, then with respect to velocity in the real situation, your friction start to decrease. So this one is just a change in the value of the friction. What you ideally take Fs max, then a straight line, it is the normal diagram. But in actual, this is the actual diagram we have drawn, my dear. Yeah, self-adjusting actual diagram we have drawn, my dear, like this. Getting? Yes. So this one is the, even the actual diagram in the real situation is not this. This is the actual diagram, but we deal with the low velocity or low speed problem. That's why you just think that static friction is a sudden drop into the dynamic or the kinetic friction, and after that they become constant, my dear, after that. Now, are you not feeling in this entire problem there is one issue that, sir, if you are able to calculate the value of F max S, the solution of every problem is there? Because are you not feeling in all the thing there is only one important point, that is Fs max, my dear? Yes or no? Because Fs max is known to us, I'll be able to know what numerical value of the force I am going to apply on that body. Is it under the static condition, dynamic condition, NSL should be applied, equilibrium should be applied. So from here we must know what is this static value of the friction, my dear. Generally we have studied that whenever body is under the applied force W, my dear, then a normal reaction will be developed in this body, that is N, due to the contact force. And if you will apply the force P, my dear, then one more friction force develop. Again, this is the contact force. If I consider, then this F force and this N force, they both are the contact force. Friction force and the normal force, they both are the contact force. And if I want to represent these both the forces, my dear, then I can write this N is the normal force, F is the friction force, and after that if I draw this arrow, then my dear, this arrow is this arrow is the resultant. But just a minute, Akif, I want to come that particular point where you maximum of the student do the mistake. Sir, in this case my point is, can you increase this value of F further? Are you able to increase this value further, my dear? Yes. If you increase this P, then F will increase. Yes or no? If you again increase this P, then F will increase. But what is the last limit of F? Can I say the last limit of this F will be equal to F max? Is it or not? So for given surface, this value of F max and this value of N, is it the constant or variable, my dear? Now F max and N, because F is variable, F is changing with respect to applied load. F max and N, these both values are constant or variable. 100% constant. So if I will write this numerical value, my dear, then this will be equal to R max, and this angle will be known as friction angle. So let me tell you, this phi is existing only for the maximum value of the friction. Maximum value of the friction, Akif. So in this case, friction force is maximum constant angle. Friction angle is, that is phi, is the maximum friction angle. Sakshi, just give me 1 minute. Sakshi, just give me 1 minute. After that, can I write from here that tan phi will be equal to Fs max divided by n, and after that can we write that Fs max will be equal to, let me write this value as a mu s into n, my dear. Now the problem is, can you please tell me value, can you please tell me from here, everyone, this value or this formula, my dear, is valid for all the numerical value of the friction or only a single value of the friction? What do you say? Because in the previous problem, when you see the problem or when you see this diagram, then you feel there are 100 of the friction force value can exist. But this formula is valid for the 100 of the friction value or only for single value? In the topic of tipping, we are here to discuss that point, how this value or this couple of P and F is balanced, because if you apply the body, sometimes it tip, rotate from the horizontal, sometimes it does not. Yes. Okay, good. We are coming on this point. I think you want to write shift, if I'm not wrong. Teju, आप शायद shift लिख रहे हो, only static. Not only static, Ajay. Not even only static. This is going to tell you only the single value, that is Fs maximum. But the main problem is you have derived this answer for the single value, that is Fs maximum, but in all the value of the friction force you blindly apply the formula. Let me tell you, my dear, this formula is only valid for the limiting condition, not for all the condition. Limiting condition. Sir, if the friction or applied load is less than this limiting condition, then friction force is blindly equal to applied load. And if the applied load is more than this limiting condition, then friction force will be the same and question will be related to NSL, Newton's second law of motion, or the dynamic problem. Are you getting this point? Similarly, I can also write, my dear, that Fk max limiting condition will be equal to mu k into n, my dear. And in general, you must know that the value of mu k is less than the value of mu s. Acceleration will come, NSL will come, or you can say the dynamic problem will come, my dear. After that, let's try to draw the direction of the friction force, my dear. If it is the problem, how will you draw the direction of the friction force? Sir, in general, there are two bodies like this. Sir, the problem is, how will you, because in the topic of friction, 90% of the engineer feel the problem to draw the direction of the friction force, nothing else. Maximum 90% of engineer feel the problem to draw the direction. And again, if you are feeling the problem in the friction topic, my dear, then you are doing the mistake at two places. One, you try to solve the problem directly. One problem. Second, you are not having the concept of dynamic and static. There are only two possibilities. You can make the mistake. One, if you try to solve each and every problem directly, you will get the mistake. You will do the mistake. Sir, in this case, there are two bodies, body 2 and body 1. In body 2, there is one string. That's why there will be a tension. Now, after that, my dear, alpha. After that, try to represent all the force first, then move forward. What is the meaning? Sir, if 1 is there now, then definitely W1 will also be there. Okay. After that, my dear, reaction will also be there. And after that, if body 2 is apply the normal reaction, body 1 is also apply the same normal reaction like this. And again, there is also one more force acting on the body, my dear, that is W. And the normal reaction will come at this point, that is N2. The problem is, during representing these all the arrows, what you do, you try to calculate that N1 will be equal to W1 substitute W2, N2 will be somewhere like this. You need not to do like this. आप सब represent करना सीख लो. Once you draw the arrow, and that is the beauty of free body diagram, my dear. After that, now you try to think all the representation almost you have drawn, only the last portion is left, that how will you draw the friction. So friction generally apply in the opposite direction of the relative motion. It is not motion, relative motion. It's okay, it's okay. It's okay, Teju. Relative motion. How the relative motion? Sir, if this body 2 and there is one surface 3, my dear. So if you want to check the relative motion of body 2 with respect to body 3, what you need to do? You sit on the body 3. Body 3 means surface. Then you just feel that I am sitting on the surface 3, and now I need to ask that if I sit on surface 3, then how this surface 2 will look like. Is it moving, stopped? If it is moving, in which direction it is moving? So if I will sit on surface 3, then surface 2 look like moving in the rightward direction. That's why friction on this part must be leftward, opposite to relative motion. Is it okay for all? Similarly, now you need to check what is the relative motion of body 2 with respect to 1. Then you sit on the body with respect to which motion is to check. And then you ask yourself, if I sit on body 2, then how the motion of, if I sit on body 1, then how the motion of body 2 look like? Then definitely it is rightward, opposite direction. This is like F1. After that, now the next question comes, my dear. If I want to check what is the relative motion of body 1 with respect to body 2. So with respect to what you need to check the motion, now you sit on that body. You sit on this particular body and ask to you yourself, if I am sitting on the body 2 and if I am sitting on the body which is already moving, how the motion of body 1 look like? Then your answer is, sir, I feel this body is moving in this direction. Yes or no? Because already you are moving. Even the body number 1 is not moving. But I need not to check the absolute motion. I need to check the relative motion, my dear. That's why friction on it will be equal to F2, F1. After that, what is the numerical value of the friction? You have already calculated, mu1 n1. What is F1, my dear? Mu1 n1. What is F2, my dear? That is mu2 n2. So in this case, all the force you have derived. Now after that, if all the force you have derived, my dear, what after that you need to do? If it is the equilibrium condition, sigma h0, sigma v0, that's all. Are you getting my point? Sigma h and sigma v is 0, that's all. If it is unbalanced problem, apply NSL, get the answer. If you represent all the force, then 90% of the problem will be solved by NSL or, my dear friend, by equilibrium condition. Now you need to derive, if it is the equilibrium condition, what will be the answer? Sir, I can write P will be equal to, my dear, P will be equal to F1 plus of F2. Is it or not, my dear? And in this case, T cos theta or cos alpha will be equal to F1. Are you not getting all the relations? After that, you will get the value of F1 and F2 in the term of N1 and N2. And then definitely you will get the all reaction. But this one is the condition for equilibrium condition. Sir, what is equilibrium? Equilibrium means all the forces are applied in such a way that they are applied up to the limiting condition. So this is all about the free body diagram. Can you please tell me, is it clear to all? How will you draw the free body diagram? Can you please write in the comment section, my dear? How will you draw the free body diagram? All of you? Everyone? Good. Great. Let's move forward. Similarly, let's check what is the friction force on the inclined surface, my dear. If I will apply the force in this direction. Like this is the friction force. This is mg sine theta. This is mg cos theta, and P force is applied in this direction. Because P force is applied in upward direction, that's why friction force will act in downward direction. So in this case, can we write for the equilibrium, P will be equal to friction force plus of mg sine theta, my dear. And from here, the P force will be equal to mu mg cos theta plus of mg sine theta. Or from here, I can say P. Just to start the motion required is mg is common, my dear, mu cos theta plus of sine theta plus of sine theta. Similarly, if I just want to know what is the applied force to lower the force, then definitely mg sine theta will act in the same direction, but friction force will act in the reverse direction in the same way. So what is the value of P? Can I write P will be equal to F minus of mg sine theta. If I'll substitute the value of F, then P will be equal to mg common, and this value will be equal to, my dear, mu cos theta minus of sine theta. Or from here, the numerical value of P, just आपको एक बार relative motion आ गया. If once you are able to get the relative motion concept, my dear, you are not going to feel any problem to write these all the equation, because you are able to draw all the force. Then next, if I'll write the angle of repose, then force required to drop the body in the downward direction is 0. Then definitely, my dear, in that condition, mu cos theta minus of sine theta will be equal to 0, or I will write mu will be equal to sine theta divided by cos theta, or from here I can write mu, that is also equal to tan phi. Tan phi is friction angle. If it is equal to tan theta, or if I will write phi is equal to theta, what is meaning of it? Theta and phi. What is meaning of it? Meaning it, if the phi angle of friction is exactly equal to angle of inclination, then in that condition, my dear, angle of repose or body will start to move in the downward direction automatically without any forces. This is the angle of repose. Few 1 marks question may be asked. After that, someone of you was asking, sir, what is the meaning of tipping? Or someone of you have just asked, I don't know. I think Shashi, you have asked now, Kiran? Yes. Sir, the force P and, my dear, this friction force F, they are just making a couple. When they are making a couple, they will try to rotate the entire body like this. But sometime when you apply the force on the body will not rotate, body will not tip about the corner point. Reason? You are not able to apply the sufficient moment to rotate the body. It means something is opposing. What is opposing? Sir, when you apply the force now, that there is a important property in this normal reaction that is having the self-adjusting property. Means as you apply the force on the body to stop the rotation, N will start to change its position. So this N and this W, my dear, will make a couple. They both will make the couple. And if you want that this couple must be resisted, or you will apply the higher couple to rotate this body, then couple due to this P and the friction, my dear, that is P into H, must be equal to or greater than couple due to W into B by 2, or H must be equal to W B by 2P, my dear. And I know very well limiting value of the 2, if body should not slide, only rotate, then limiting value of the P must be less than or equal to mu N, or P must be less than or equal to mu into W. If I substitute all the values, then for this rotation, my dear, I require V divided by 2 mu is the answer. You require minimum height to rotate, to tip the body. Otherwise, there will be auto adjustment of the normal reaction to oppose your applied force. Okay. So this is the amount of H where you want to apply the force if you want to rotate anything. Okay, good. Exactly. Yes. Exactly. Point is clear? Sasi, it was your question. Is this point clear? There is one important normal reaction property that start to adjust itself whenever you will apply the any force on it, my dear. After that, application of the friction on the machine, my dear, is a very important topic. Generally you ignore, but topic is very easy, my dear. Like this. There are 4 important topics in the engineering mechanics. Even there is also one more important topic like clutch and brake. But clutch and brake is the specific topic in the mechanical engineering, my dear. Very good. Clutch and brake is the specific topic in the machine design. That's why this topic is not included in this session. Engineering mechanics, clutch and brake we are not going to cover here. That will be covered in the topic of machine design. Sir, rolling friction. Generally, there are 2 types of rolling. One rolling is when, my dear, this surface on which rolling is occurred, then both the surface and wheel are the rigid body. If both are the rigid body, then, my dear, if it is under the pure general motion, general plane motion or the rolling motion, then at that time no external force is applied. Then at that time, my dear, the velocity, relative velocity at this point will be 0. And if the relative velocity at this point will be 0, under the no application of the force, friction force will be 0. Getting? If it is the pure rolling, because we know very well, when it is a rigid body example, in the rigid body example, there will be a point contact. When point contact is there, then relative velocity already we have discussed in the eye center topics. See, that velocity is 0, that's why friction is 0. But in this case, when I will apply the force like this, even the body is rolling like this, but if I will apply the force like this, then what will happen? Even from this point now will start to slide in this direction. I am not feeling this point will start to slide in this direction, my dear. That's why the friction force in this condition will act in this particular direction. If the force is applied at the center or the below center, you just try to pull the wheel in the forward direction. Yes, it will make a couple, my dear, like this. Exactly. No. This is not a rolling friction in the deformed body. This is just a friction, how it is acting, then the body is rigid body. For what you are dealing with the rolling friction, that is the different topic we are coming on at after that. Sir, even if the body is rolling like this, and suddenly you apply the force on it, on the top, then again what in general condition, it was the problem of the wheel in pure rolling. But what you have done, my dear, you have just added one extra force so that these all the points which were having just instant velocity 0, they will start to move faster under the application of P. Because in this condition, at this point, if the instant velocity is 0, but when you will add one force, are you not feeling these all points will start to move in this fast way? So when they are starting to move in the fast way, then definitely, my dear, in this case, friction force will be applied on the body like this. If all the wheel and the surface are the example of the rigid body. Sir, this is the general direction. This is the general direction of the friction in the rigid body, my dear. First of all. So after that, what is the condition of the rolling friction, my dear? We know very well that in real, both wheel and surface are not rigid. Are you getting my point? Both are not rigid. In reality, neither wheel nor surface is rigid body. So in that condition, if I consider the actual condition, my dear, then in actual condition, the condition of wheel are somewhere like this. They deform like this. Is it or not? Surface deform like this, and after that, if I consider how this normal reaction act, how this normal reaction is coming into the picture, then the point is somewhere like this. Maximum reaction is very in uniform way, my dear. Is varying in the uniform way like this. This is the actual condition we are dealing with. But when this body start to move, whenever any deformed body will start to move, will start to roll over a muddy surface, or you can say over a deformed surface, my dear, then again, whenever you will try to apply the couple like this to rotate this deformed surface, this is a curvature. Oh, sorry. This one is a curvature. Like this. Like this. So there is a curvature somewhere like this on the muddy surface. Lot of time this picture you have seen, my dear. This important picture, lot of time you have seen. This is the W. So in that condition, when in the muddy surface, this entire wheel is rotating, then you feel most of the force is applied somewhere at this point, because normal reaction what you are dealing in the rest condition, it generally change like this. Maximum normal reaction is coming on the forward end, my dear, like this, on the forward end. So normal reaction shift in this condition from the center of the body, normal reaction shift like this. If I'll represent the resultant of the normal reaction, it is located at some time, located at this some place, sorry, like this, and this position is B. So if you want to pull the body, then definitely you try to pull that entire vehicle, by P, and this radius is R, my dear. So in the rolling friction, you need not to apply the sliding. You need not to apply the concept of sliding. In that condition, you want to tip the entire member from this point A, my dear. Have you seen in village, in rural area, even in some muddy surface, your car, especially most of the time, tractors are stuck in these muddy surface. Then what we do? We just take a rope and then we start to pull with this force, my dear. Do you know what they try to do? They are not sliding at that time. What they are doing? They are trying to roll the body from this entire point, because maximum support reaction is there, my dear. So you try to rotate the body. How? We want that P into R couple provided by you must be, this N and W is also making a couple. This N and W is also making a couple, that must be greater than or equal to, W into B, or from here P applied load must be equal to or greater than W into B into R, my dear, where this W into V divided by R, my dear friend, is the force required to get out this entire wheel from the mud surface. And this V is known as coefficient of rolling friction. And let me tell you, now it is having the unit, my dear. Coefficient of rolling friction is having the unit. It's not a unitless quantity. Because let me tell you the complete point. Sir, coefficient of friction, rolling friction, or the rolling resistance is nothing but it is the shifting of the normal reaction from the center. It is the distance of shifting the normal reaction from the center, my dear. Are you getting my point? Yes. This is the coefficient of rolling friction. After that, let's solve this question. A steel of this is my dear 0.3 mm. 0.3 mm. Teju, write the correct answer of this question. What will be the force required to roll the wheel along the rail? P you need. Anyone? Write the answer. Sasi, Teju, what is the correct answer of this question? Let me check your correct answer. Can you please write the answer in comment section, my dear? What would be the correct answer of this question? Yes, I am waiting for the correct answer from you guys. Anyone? This is 0.3 mm, my dear. Coefficient of rolling resistance or rolling friction is 0.3 mm is given. So what is P? Can we write like this? W into V divided by R, my dear. What is W? W is 500. What is B, my dear? 0.3. What is R? How much? Radius 300. So what we are getting? Is it 1.5? No, it is 5 into 0.1. Answer is 0.5. Are you not getting A answer? Yes. Only one of you have got the answer. A is the correct answer. Yes, very nice, Ajay. Wonderful. A is not answer. Sir, diameter is given. Why you are not feeling? Diameter is given. Okay, 1 means A. Nice. Great. Let's see the second problem, my dear. Friction on wedge. Sir, wedge is a simple machine that is often used to transfer the applied load into the merged larger load. Like this. Generally, this one is the weight, my dear. This one is a very heavy weight. On this heavy weight, you have seen some wedges like this. So after that, what exactly you need to do? So this weight you want to lift in this direction a little bit to adjust something. That's why you are applying some force, my dear, like this. So due to the application of the force, this entire system, it is moving like X, then this entire system is moving like Y, just for example. This is the ultimate function of the wedge. Wedge means you are applying a very little bit amount of the force to lift this very heavy weight in the upward direction. And this W is known as, my dear, load, where this P is known as effort. X is known as movement of the effort and Y is known as movement of the load. So from here, sir, if you are able to draw the free body diagram of both, then you will be able to find the answer of each and everything. Sir, in this case, let me write 3 surface is there. 1, after that 2. This one is 3 surface. Okay, 3 surface are there. Coefficient of friction are also there. If you all are able to draw free body diagram, what concept was given to you in today class by Abhinav Sir. Very important concept is given by Abhinav Sir, that you will be able to draw the free body diagram for any problem. So in this case, my dear, the first problem is given to us like this. Second problem, let me draw here. Wedge, let me draw here, my dear. It is something. Weight of the weight is negligible. That is the reason you are not going to consider the weight. And this is in original. That is not an assumption. Because generally the weight of the vehicle, weight of this heavy plate W is very high. And you take a very small wedge of wood or steel or something like this, whose weight is hardly 1 or 2 kg. And this weight is 100 kg like this. So that's why weight of this wedge is very low. So in this case, this is the body number 2, my dear, and this is the body number 1. If you are able to represent all the reactions, then first of all, W is acting in this direction. Normal reaction is acting in this direction. And one normal reaction is also acting in this direction. And 1, 2. Same normal reaction will also act on opposite end, that is N1, 2, my dear. If the body is moving in the forward direction, one more normal reaction is acting in this direction, N3. After that, if this body is moving in this direction, friction force on this one will act in this direction. That will be equal to F3, my dear. Its value will be equal to mu3 into N3. Very good. Wonderful. After that, if this is moving in this side, then friction force will also act in this side. That will be equal to F12, and that is equal to F2 into N12. Into N12. Is it clear to all? N12, my dear. Similarly, there is also one more friction that will act in this direction. That is F12, my dear. That is equal to mu2, equal and opposite reaction, N12. And similarly, because this body is moving in upward direction, there is also one more reaction that will act in this direction, that is equal to friction force F1, that is given by mu1 into N1. These are all the friction forces or all the free body diagram of actual body. And my dear, all these wedges we have drawn. After that, if you are able to write all the sigma h is equal to 0, sigma v is equal to 0, easily you can find the amount of P to lift this weight W, my dear. बस यही हमको solve करना होता है. But in exam, let me tell you in advance, my dear, if the question from ways comes, then it is suggestion for all of you, always try to solve these type of problem at the last of the question paper. Are you getting my point? Exactly at the last you need to solve these type of problem, because these type of problem requires so much of time, so much of concentration. Most of the time there are full chances to make these type of question as a wrong. 100%. You can skip if you don't have the time, but if you are having the time, because in these all the type of wedge problem, my dear, there are 4 equation. हमको 4 equation बनानी होती हैं, because you will start from W, then you will calculate the value of N1 with one equation, N2, N12 second, N3, my dear, third equation, and by combination of N1, N2 and N3, you find P as a last equation. So that is the reason you require 4 important equations. If you really want to find the value of force P from that weight W, my dear, that is the problem. 4 equation को solve करते करते दिन निकल आता है कभी कभी. That's why this is a suggestion that you try to solve these questions at last. Yes. After that, there are few important parameters, my dear. Yes, equations are same. Equations are almost same until unless geometry of this wedge surface not change, my dear. If geometry change, again next equation will come, but equation will be 4, because there will be a support from 3 ends, and one is the 4th one, that is the applied force. That is the reason you have to drive the 4 minimum equation to calculate the value of force. After that, there are few important parameters you need to know from these all the machine where the weight is applied and you want to lift the weight from the applied force, my dear. Like one is the velocity ratio. Velocity ratio is generally written as ratio of the displacement traveled by the effort to the displacement traveled by the load. Similarly, mechanical advantage, it is the ratio of the weight lifted divided by effort. Third one, efficiency or the mechanical efficiency, it is the work done divided by load, work done by the load divided by work done by effort, generally work done by effort. Okay, now yes, most important and easy question for you guys, that topic of screw jack, my dear. Screw jack, what is? Screw jack is used to lift a very heavy weight with the low effort, my dear, very low effort. W weight you want to lift, and P force here you are not applying, no, you are calculating at this point, my dear, at this point, at the end of the screw, and this is the R, my dear. This lever is just added here to give you the less effort, because when lever arm will be increased, then this value will be definitely decreased. To decrease this value, you will increase the length of this lever. Otherwise, what numerical formula you are calculating, that is apply at this particular point, my dear, where you can write the value of the P lift can be given by W 10 phi plus of alpha, where the value of the phi is the friction angle, and where the value of the alpha, my dear, can you please tell me? Helix angle. The value of the alpha is helix angle, or P, if you want to lower the weight, that will be equal to 10 phi minus of alpha. And the benefit of this topic is you are not going to change, you are not going to drive any new formula. ये सिर्फ formula याद कर लो, and how you calculate the value of alpha, like in this case, my dear. If I just want to calculate the alpha, then from here, my dear, 10 alpha can be given by 10 alpha can be given by pitch divided by pi d. Helix angle from here can be given by pitch divided by angle from here can be given by pitch divided by pi d. Pi d is the parameter. After that, if I just want to know what is the self-locking condition, my dear, then for the self-locking condition, there is only one possibility, my dear, that you want self-locking condition that friction angle must be greater than helix angle. Generally, I can give you the derivation कि ऐसे करके आता है, इस तरह से आता है. Self locking condition is nothing but you want this P lower must be greater than 0. Greater than 0 means W 10 phi plus minus alpha must be greater than alpha 0, or it must be greater than 10 0, or phi minus alpha must be greater than 0. Yes. Tell me. Yes, there is, I think mention किया हुआ था. Aptitude and English and reasoning date will be 27, 28 and 29. There is also date mention, I think. I'll just share the screen at last, don't worry. Yes, there. Okay. After that, screw jack efficiency, my dear. Then the efficiency of the screw jack to lift the body or to lift the weight, it will be equal to, my dear friend, 10 alpha divided by 10 phi minus plus of alpha. Similarly, if you want to check the efficiency to lower the screw jack, my dear, that is 10 alpha divided by 10 phi minus of alpha. That is the general efficiency of the screw jack. Okay. After that, this is the simple condition for the screw jack. Here you must know only one thing, what is and how the numerical value of the 10 alpha I have just calculated. 10 alpha is pitch divided by pi d, or 10 phi, my dear, it will be equal to coefficient of friction. You must know these all the parameters. After that, let's solve it. How many of you are getting the answer of this question? Mechanical advantage is asked, my dear. Mechanical advantage is asked. Anyone? Let's see how many of you are getting the answer. Weight W is given. Diameter and pitch is also given. Coefficient of friction is given. So can we write from here that 10 phi will be equal to 10 inverse into 0.05, my dear, and alpha will be equal to 10 inverse into pitch. How much is the pitch? 10 divided by pi into 200 mm is the diameter. Are you not able to find the angle, my dear? Please, can you write the answer? Can you please write the answer? What exactly you all guys getting, my dear? What exactly you everyone getting in this case? The value of phi and the value of alpha. Yes, any one of you? Can you please tell me the answer, my dear friend? Similarly, the mechanical advantage we have, or efficiency to lift, we have just written, my dear. that efficiency of lift will be equal to 10 alpha divided by 10 phi minus of alpha. Similarly, the mechanical advantage can be written by W divided by P, my dear. W is okay. P will be equal to 10 phi plus of alpha. Plus of alpha. So what is the answer? 1 plus 10 phi plus of alpha will be the answer. I just want to know the numerical value of the efficiency. Efficiency I just want. What is the efficiency, my dear, we are getting? What is the mechanical advantage we are getting in percentage? Anyone? What is the mechanical advantage and what is the efficiency we all guys getting in this case, my dear? Yes. Ajay, what is the mechanical efficiency? Teju, जागो जल्दी से और mechanical efficiency बताओ. You can't take so much of time to find this simple level of problem, my dear. Yes, any one of you? Good. Teju say that 24.12% is the efficiency. Yes. Ajay, are you getting the same answer? Ajay, my dear, are you getting the same answer? Good. Very good. Wonderful. बहुत सही. Excellent. Let's move forward. After that, let's see the topic of belt, my dear. The belt drive are design. Yes, it is necessary to determine the friction force developed between the body. Generally, when there is no friction, it is okay, but when there is a friction, then T1 by T2 or T max by T mean. When the belt is moving like this, it is equal to e raised to mu into beta, where the beta is the angle of repose, where the beta is the angle of contact. With the help of the single formula, you can solve the problem. After that, my dear, let's start the next topic, kinetic of rigid body. Most of the time, at least one question you will get from this topic, my dear. At least one question you will get from this topic, and from here I am going to tell you, I am going to give you the procedure of each and every component. Sir, if it is the CG, my dear friend, if this one is the CG and you will apply the force at other than CG, at this point if you will apply the force like this, and this is the eccentricity E, like this, then first of all you need to know, if this force can be shifted at this point or not. Yes sir, you can shift at this point by apply to equal and opposite force like this. So this force P will apply or will create the rectilinear motion in this case, and H per the rectilinear motion, my dear, I can write Fu or the Newton second law of motion. I can write unbalanced force will be equal to M into ACM, and Tu unbalanced torque, if the body is rotating about any point, then it will be equal to I alpha. Sir, to apply the kinetic of the rigid body, you need to focus two important points. Listen these 2 points very clearly. To apply the concept of rectilinear motion and, my dear, this Newton second law of motion for rotation, you need to check two most important points. What are these? First point, if the body is rotating about a point under the torque, unbalanced torque, blindly you can apply the concept of rotation. Tu is equal to I alpha. Second, you will check if the center mass means centroid of the mass, is having the linear acceleration. You can blindly apply the second concept, that is, my dear, this one. And the third one, you can also check that ACM will be equal to alpha into R, where alpha is the angular acceleration and R is the distance of the center of mass from the point about which the body is rotating, my dear. Let's try to apply the same concept in few problems. This is the mass moment of inertia which will be required for you About the CG, I have calculated. If it is the uniform thin rod, what is the MOI? We have written. If it is the circular solid disc, we have already written. Hollow solid circular disc, all the points we have written, which will be required for you. Let me move sideways. Otherwise, I'll share the entire PDF with you in my Telegram channel. Don't worry about this. Then procedure to apply the Newton's second law of motion. If the body is in general plane motion or subjected under non-concurrent force, means force are not applied at the CG of the body, then body can translate under this condition and body can also rotate, my dear, under this condition. That's why you will try to apply both the concept. If the body is rotating, blindly apply unbalanced torque is equal to I alpha and force is equal to ma, my dear. Similarly, if I apply the same concept, then my dear, from here you can feel that entire body can be rotated under this torque T, can be rotated like this. T is the torque or tension, and this body can be felt to torque or to rotate about this. Now, what is the value of the tension? Any one of you can give me the answer. What is the value of the tension in the code? Because I can see the entire body can rotate about this point like this. So can I write what is rotating? Can I write unbalanced torque will be equal to I at A into alpha, my dear? Yes, sir. So what is unbalanced torque? W into R, my dear. What is I about A? That is equal to 3 mr square divided by 2, my dear, into alpha. This will be cancelled. M will be cancelled with this G time. Then alpha will be equal to, my dear, 2G divided by 3R. So alpha is known from here. Can you please tell me what is the value of ACM? Definitely ACM will have some acceleration that will be equal to alpha R, or that will be equal to 2G by 3. So what is NSL? Sir, is center mass is having the linear acceleration? Yes. Apply NSL of linear motion. Apply NSL for linear motion. What will be the answer? NSL for linear motion. Can you please tell me the answer? Yes, sir. NSL of the linear motion, we can easily write that W minus of T will be equal to M into ACM. M into ACM, 2mg divided by 3, or 2W by 3. So what is the value of the tension, my dear? That will be equal to W by 3. It will be the tension. It means mg is divided into two parts. One part is increasing the acceleration, and my dear, second part is contributing into the tension. Okay. Next, work, power and energy. Work, power and energy. Sir, if you apply a force, if you apply a force, my dear friend, on a body like this, if you apply the force on a body, a force is this one and displacement in this body is ds, my dear, then what is the work done? Can we write? Well, work is the force into displacement in the direction of force. But if the force is constant, then it will be Fds. But if the force is not constant, then you have to do the integration. So in this case, if I draw the diagram between the force and the displacement, it can be given by that force can be very like this, and work done in this condition can be given by F into ds. Very nice. Yes, Ajay. F into ds. Like this. Like this. So what is the area of this diagram? Area of this diagram will be equal to F into ds. So can I write work done is also equal to area of force versus S diagram. There is also one more important relation we have drive. If you are able to drive force versus displacement diagram, my dear, then work done will also be equal to force versus displacement diagram. After that, let's discuss few other form of the energy like kinetic energy. Yes, 1 by 2 mv square is the kinetic energy. Similarly, kinetic energy of the circular motion 1 by 2 into I omega square, and if it is the question of the rolling or the general plane motion, which is the combination of both, that will be the summation of both the energy. 1 by 2 I omega square plus of 1 by 2 mv square kinetic energy. After that, conservation law of energy. Conservation law of energy states that energy neither create nor be destroy. It can be transferred from one form to another form. Like if you are moving from this particular point, either you are moving in this case, you are moving like this, you are moving like this, you are moving like this. If the total height is same, my dear, so H per conservation law of energy, this is the state 1, this is the state 2, 2, 2 and 2. If I'll compare all these points like this, my dear, then I will get that what is the total energy at point 1, it will be total energy at point 2, my dear. What is the answer? Total energy at point 2 will be equal to potential, that is mgh, plus of kinetic, that is mu square, will be equal to 1 by 2 mv square, my dear, where this is u and here the velocity is v. So velocity of all the point from here we will get the same if we are not going to consider the friction तेजो. अगर friction को consider नहीं करते हो, then velocity at all the point will be the same, my dear. Good, very good. Then momentum. Momentum is a property generally of a moving body when the body has it by the virtue of its mass and it is equal to product of body mass and the velocity, my dear. So the momentum can be written as vector p. It will be equal to m into v, my dear, where the momentum is the vector quantity. Vector quantity, it is the property of moving body to determine that what will be the time required to stop this entire body under the action of constant force. This point और आगे जाके थोड़ा clear होगा like this. If I'll write the impulse if I'll write, then impulse is used to describe or quantify the effect of the force acting over the time. Like impulse J is written by F into dt, my dear. This is the impulse. This one is the impulse that is represented by vector J, and this is again a vector quantity. Sir, if you apply Newton's second law of motion, then H per, my dear, H per Newton's second law of motion, NSL, what we have discussed, the rate of change of momentum, na? Momentum, we write like force, is it or not? If I'll write P final minus of P initial, it is equal to integration of Fr into dt. So what is this Fr into dt, sir? Impulse. So in this case we are getting that total change of momentum between two condition of the body when no external force is applied is not going to change. What is the meaning of it? If the external force is equal to 0, my dear, force is equal to 0, then the initial momentum and the final momentum is never going to change. Never going to change. कभी change नहीं होगा. If the applied force is 0, no resulting force is acting on the body or the system of body is 0, then momentum of the body is not going to change. This will be always same. What is meaning of it? Mi into ui will be equal to mf into uf. This is the momentum of a body, single body. After an interval of time, this momentum is never going to change. Let's apply the same concept on the system of bodies. What is the meaning of this? Let's consider this as one system of mass m1, velocity u1, mass m2, velocity u2. After the collision, my dear, collision, mass of m1 has the velocity of v1, mass of m2 has the velocity of v2. And if the total momentum is not going to change, so I can write P1 of the entire system before collision is equal to P2 of entire collision after the collision, my dear. Can I write what is the momentum before collision? M1 U1, complete system, not a body, plus M2 U2 will be equal to M1 V1 plus of M2 V2. What is the meaning of it? If no external force is applied on the body, then total momentum of a system before collision and after collision remains same. Similarly, there is also one more point to define the type of collision, that is going to define the coefficient of restitution. When two bodies collide with each other now, then definitely they will have the two important activity. One, first they start to deform, second they start to separate or recover its deform. If with the perfect elastic body, my dear, this will be 100% try to recover itself. That is the reason coefficient of restitution is just going to give you the idea of impulse during the recovery to the impulse during the deformation. It is generally given as velocity v2 minus v1 divided by u1 minus of u2, that is the coefficient of restitution. Like this. Coefficient of restitution, it's like this. Similarly, as per the coefficient of restitution, there are three types of collision. Perfectly elastic collision means perfectly recovery of the collision is there. Can we write like this? First, energy will be conserved like u1 is square plus of m2 u2 is square is equal to 1 by 2 m1 v1 is square plus of 1 by 2 m2, my dear friend, v2 is square. This is the recovery of perfectly collision. Similarly, if no external force is applied, then definitely, my dear, this is already recovered. That this concept will be 100% valid in this. And after that, because modulus or the coefficient of restitution is 1, then in this case v2 minus of v1 will also be equal to u1 minus of u2, my dear. So in this condition, all three conditions will be valid. All three will be valid in the perfect elastic condition. Are valid. Are valid. Second, if I'll write perfectly plastic collision means E is equal to 0. What is the meaning of it? V2 is equal to V1. That's why E is equal to 0. It means both members stick to each other. After that, if I'll write the kinetic theory, it will not be valid, my dear. Why? Because energy is wasted. They are stick to each other. You are not eligible to apply the concept of kinetic energy. Then what is the concept you can apply? There is only one. What is it? M1 U1, because it required only the force. M2 U2 will be equal to M1 V1 plus of M2 V2. M2 V2. After that, partially elastic collision, mass conservation. Yes, mass conservation will also be there. Mass conservation will also be there. Exactly like a clay, you just throw over a boundary wall, throw over a floor. Partially elastic. Again, partially means there is also some loss of kinetic energy. That's why complete recovery is not possible. partially elastic recovery. In this case, coefficient of restitution will be equal to V2 minus of V1, my dear, divided by U1 minus of U2, coefficient of restitution. These two formulas will be valid. Kinetic energy will also not be applied here. Do you know the reason? There is loss of the energy due to the deformation. Recovery is not possible. After that, if there is a wall that is falling on the horizontal floor, and if the initial height is h, my dear, then after nth bounce, what is the height traveled after? After nth bounce, what is the height traveled by the body? So I'll write after nth bound, if original height is this, that will be equal to 2n into h, my dear. Even we are having the derivation, but this is the revision, my dear. We are just recovering all the theoretical part, all the important point to solve the numerical. Second, what is the total distance covered before stop, if E is the coefficient of restitution? What is the total distance? That total distance D will be covered by the wall. It will be original height from where it is thrown, 1 plus of E square divided by 1 minus of E square. Like this. Total distance covered by the wall, my dear. If the ball is thrown on the floor, then what is the total wall or total distance covered by the ball before it stopping it? रुकने से पहले. After that, centroid of the area. CG, most of the time you feel the problem. My dear, in this topic of the CG, we are having two important way from which this question may be asked. Sir, what is the first one? First one, my dear, is CG of the discrete change body. What is the discrete change? From one body and second body are clearly visible to us. Means there are fixed figure. CG of first is known to us, CG of second is known to us, but they are subtracted, they are added. So for that type of cross section area, the CG of the x bar can be given by, my dear, A1, CG of the first one, A2, CG of the second two, divided by A1 plus minus A2, my dear. Plus minus means plus for addition, minus for subtraction. Similarly, A1 y1 plus minus A2 y2 divided by A1 plus minus of A2. This is the CG. Plus minus, my dear. This is the CG of the discrete change. This part I am not going to discuss detail. Do you know the reason? Sir, in सब part के तो question हम बहुत आसानी से कर लेते हैं. Yes or no? These type of problems we solve very much in a very well planned manner, but we don't know if some irregular shape are given to us. What do you say, Ajay? If some irregular shapes are given to us, parabola is given to us, ellipse is given to us, cubic parabola is given to us, arc of a circle is given to us, how will we be able to calculate the value of CG, centroid of these points in reality? These are the questions. So to solve these type of problem, I have prepared already a procedure. If some irregular shape are given to us whose centroid of gravity is not known to us, so what you will follow the procedure, that is the important point, my dear. First thing, and this important problem I will explain with the example, my dear, so that this topic will be more clear to you. One way is to solve the entire problem related to Cartesian coordinate. Cartesian coordinate means all the irregular shape other than circular you will be solving with this concept, my dear. Like, first of all, from the irregular shape define the origin. Like in the next problem, sir, this is a parabola where the equation is y is equal to x square, my dear. Okay. Now, after that, first of all consider a origin. Yes, sir, consider. After that, second one, my dear, take a small strip. It is up to you. You can take a X strip, you can take the Y strip. Take a very small strip to the cross section. Taken, sir. Next step. Either in horizontal or in vertical, it is up to you. Then find the area of the strip. Can I write the area of the strip? This is dx, this is y. What is the area of the strip, my dear? Can you please tell me? Sir, x into dy. Wonderful, wonderful. Next, Ajay, are you getting this point, everyone? Teju, all points I am going to write in this point, apply here. Fine. After that, define the center coordinate of the strip. Center coordinate. Center coordinate of strip means strip center coordinate will be somewhere here. Can you please tell me what is the x star center coordinate of strip? That is x. Y star center coordinate of strip, that is y. Is it? No, not y. Y by 2. Because total is y, then this will be y by 2. Is it okay? Is it okay, my dear? After that, apply the equation. What is the equation? X bar is x star into dA, and my dear friend, y bar is y star into dA. Okay. After that, find x bar centroid. आ रहा है ना सभी को? Are you getting, all of you, my dear? Are you getting? Next step, x star into dA. Can we write the value of x star? Sir, x dA, x dy. Lower limit of dy. We have written something wrong. Just a minute. We have written this area wrongly. Yes, yes. Very nice, very nice. That is y into dx. Sorry. Because area of the strip is y into dx. Y into dx divided by dA. Divided by dA. dA means y into dx. Yes. What is the value of y, my dear? Y is given to us how much? X square into dx divided by x square into dx into y. What is the lower limit of x? 0, upper 1, 0, 1. Can you please solve the question, my dear? What is x bar? That is x raised to 4 divided by 4, and that is x raised to 3 divided by 3, my dear. Is it or not? Is it or not? That is 1 to 0, and that is also 1 to 0. Answer will be equal to 3 by 4. Answer is 3.75 is the answer. Similarly, can you find the answer of the same problem for y coordinate? Very good, wonderful, very nice, Ajay. Yes. Can you repeat the same problem for the y coordinate? बिल्कुल सर कर लेंगे, वही तो करना है y बार करके. Nice. Okay. Sir, can you solve any problem which is given in the Cartesian coordinate? Take the strip, either vertical, either horizontal. Very nice, Teju. Good. Second, now the question come, if any problem is given in polar coordinate. Sir, what is the meaning of the polar coordinate? Polar coordinate means circular body is given and CG is to ask. So when you solve the CG of this circular body now with the concept of the Cartesian coordinate system, whatever we have written, then it will be a very lengthy integration, my dear. So it will be better that you find or you solve this problem by polar method. What is this polar method? Take the center of the circular body as a 0, 0. Good. After that, define. Okay. Second, Take a small strip at an angle of d theta. Like this. Take a small angle at a d theta, my dear. Like this. Take a very small angle at an angle of d theta. And radius is r, my dear friend. And what is this length? This length is r d theta. Then I have taken, yes, at an angle of theta. Find the area of the strip. Same procedure we are following. What is the area of a strip, my dear? Can you please tell me? Same procedure we all are feeling, that area of the strip will be equal to 1 by 2 base. Base is r theta into length. Length is r. So answer is r square d theta divided by 2. Clear to all till now? Yes. Next step, my dear. Find. Define the center coordinate of the small strip. Are you not feeling it is behave like a triangle? It is behaving like a triangle, my dear friend. Yes. Can I write the CG of this one will be somewhere here? Let me change the color. CG of this one will be somewhere here. That will be equal to 2 by 3 of r from here. Is it or not? Yes. But you need to find what is the x and y coordinate. X coordinate will be x star, my dear, like the previous problem. And y coordinate will be the y star, my dear, like the previous problem. Are you not able to find that x star will be equal to r 2r by 3 into cos theta, and my dear friend, y star will be equal to 2r by 3 into sin theta. Any doubt? Any one of you feeling? Anyone? No. After that, sir, till now we have taken. Convert the centroid in the x and y direction. Converted. Apply the equation and find the answer. What is the equation? X star will be equal to integration of x star into dA divided by dA, or it will be equal to x star 2r by 3 cos theta into dA r square by 2 into d theta divided by r square by 2 into d theta. Are you not feeling this and this is cancel out? What is the answer, my dear? This angle is changing from minus alpha to plus alpha, my dear. So what will be the integration? 2r by 3 cos theta d theta, and this will be equal to d theta integration minus alpha to plus, minus alpha to plus. What is the answer? 2r by 3 is common. That is equal to sin theta, my dear. Integration alpha to minus alpha, and that is the theta. Integration alpha to minus alpha. Can you please tell me the answer? Anyone? Yes, it will be equal to 2r sin alpha divided by 3 alpha, if I am not wrong. Is it? All of you getting the same answer, my dear? Everyone getting the same answer? 2r sin alpha divided by 3 alpha will be the answer if my calculation is not wrong. All of you? 2r sin alpha. Very good, yes. Similarly, you will calculate the y bar also. Then MOI. How will you calculate the value of MOI? Mass moment of inertia. Okay. R by 3, 82 sin alpha. 2 sin alpha. 2r sin alpha divided by 3 alpha. Yeah, I have written the same. Yes, I have written the same, sir. Then mass moment of inertia, area moment of inertia about any axis. How would you calculate? How would you calculate area moment of inertia about any particular axis? Sir, better than this definition, better than these all the point, it will be better. I'll explain. I'll give you the example from the numerical approach. so that this topic, procedure and everything will be clear to you, my dear. First of all, define the origin. About which point, about which line you want to calculate MOI, then define the origin at that point considering 0, 0, my dear, like this, like this, like this. Okay, now this is the 0, 0. What is this length, my dear? V. What is this length, my dear? D. Like this. Okay, next step. Take the small strip parallel to axis about which MOI is to find. Like you want to find MOI about the x-axis. So what you will do, take a small strip parallel to x-axis, my dear. Like this. Take the small strip parallel to that axis and find the area of the strip. Like this is the value of dy, my dear, dy at a length of y, and this is definitely the value of v already given to us. So can you please tell me what is the area of the strip? Can you tell me area of the small strip? What is the area, my dear? Can you please tell me? That is equal to v into dy. Yes. After that, take the second moment of area. Moment of area of strip. Second moment of area of the strip, can I write dix will be equal to y square into dA, or it will be equal to b y square into dy, my dear. After that, total MOI about the x-axis, can be given by integration of y square dA. Are yes or no? We write number of time. We have written number of time y square into dA. That can be written as b y square into dy. What is the lower limit of y? Minus d y2. What is upper limit of y? Plus dy 2. If I solve it, yes, just give me 1 minute. If I solve it, we are getting Vd cube divided by 12 is the answer, my dear. Vd cube divided by 12 is the answer. Sir, generally we are having that x-axis is written as area of this dA about the x-axis. So what is the dA? Sir, v into dy, yes or no? What will be the 2 time moment of this dA? So dA, perpendicular distance y into dA, first time moment, one more time moment, y into dA, that will be equal to y square dA. That is the second time or the 2 time moment, my dear. That is the second time or the 2 time moment. Is it or not? Or the 2 time moment. So that is the MOI, second moment of inertia. If I'll integrate, I'll get the answer. Let's check. Find the area, sir, found. Take the second 2 time moment of the inertia of the small strip about the axis about which you want to calculate. Teju, is the point clear? Integrate to find total MOI. So if I'll integrate the equation, I'll get like this. Is it clear to all? This is the way we calculate area moment of inertia lot of time, my dear. जो आप strength of material में use करते हो. In this way we calculate. Okay. After that, Lagrange equation, my dear. The same topic I am going to take today morning. 25 most important question related to Lagrange and virtual work. So this topic I'll discuss tomorrow in detail. Don't worry. After that, projectile motion. Generally, sometime projectile motion is asked to us, but generally it is not mentioned in the syllabus. So, what is the projectile motion? It is the motion of an object. Sir, agar about xy पूछे तो, so what you will do? You will take an area of this small strip. You will take the area of the small strip. Okay, You will take the area of the small strip and then you will take the mass moment of inertia about the xy axis, x and y axis. Then you will do the integration. Because right now you are calculating about one axis only. Then you are just multiplying with the same parameter 2 times. Then you will do the integration and then you will get the answer. Okay. Now, sir, generally 3 important parameter may be asked, but topic is not included in the GATE syllabus, my dear. That's why sometime if your luck is not good, can we add 1 or 2 questions related to this one in tomorrow's session? Teju, I think it will be more better. से अच्छा वो 2-3 क्वेश्चन ही उसके ऐड कर लें. If you allow with the MOI, with this topic of the Lagrange and virtual work, can I add 1 to 2 problem from the MOI, area moment of inertia? It will be more better. It will be more clear and write me advance. Yes. So I think mass moment of inertia clear to all. You will not feel any problem to find the mass moment of inertia. Sometime you may feel the problem to find the area moment of inertia. So it will be better. Let me add at least 2 problem. कम से कम 2 problem. One problem related to x-axis or y-axis and second problem is related to xy, what you are talking about. ठीक है? Okay, definitely. Because let me tell you, CG topic, mass moment of area, area moment of inertia, even I'll give you the complete procedure, but until unless you will not apply on the problem, मजा नहीं आएगा तब तक. Getting my point? Okay. So virtual work topic, Lagrange, and 2-3 problem from MOI I'm going to add in tomorrow's session as per your suggestion. And in this way, my dear, our entire topic is over. See you tomorrow in the morning, my dear friend. 10 a.m. Most difficult problem, most twisted problem are waiting for you, and most easiest also if you follow the procedure of 2 slides. I'll also show you in the starting of the topic related to virtual work and Lagrange that if you are able to just recognize only 2 slides, procedure I'll write in these 2 slides, then no problem will be related to difficult topic if you are feeling. ओके तो चलिए कल मिलते हैं माय डियर. अजय, तेजू, देखते हैं थोड़ा सा हंगामा मचाते हैं कल, कितने फ्लावर हो कि फायर हो, कल देखेंगे. Right? So this is all about the today's session, my dear. See you tomorrow. After the session, I'll share everything in the Telegram channel either tonight or tomorrow morning after the session. So thank you all. Bye-bye. Good night. Take care. Take care to all of you. Just revise each and every topic if you have enjoyed the session by all the 3 faculty. Just like the session, my dear. See you tomorrow. Thank you. Good night out. Good night. Sayonara. Okay.